everyone, my name is Rigved. I am a Linux sysadmin here at Director, and I'm going to be talking about LXC and Salt, mainly about LXC and a little bit about Salt as well. So I'll just start with LXC. So has anyone here worked with any virtualization technology, or do you know what virtualization is?
How many don't know? How many don't know what is virtualization? Okay, one. Okay.
So everyone else knows what virtualization or has worked with some sort of virtualization. Okay. So so there are virtualization. Basically, what it does is it will allow you to allocate more resources than are already present on your system. So that's like a layman way of putting it. So suppose you have one machine with say 8 cores and you have say 64 GB RAM on that machine, and you want to put some applications on it, and the applications should be such that are such that they might conflict with one another, or they don't require the entire resources that are available on the system all the time. Like they don't need all the cores, they don't need all the memory on it. So what you do is you put all those applications in some sort of virtualization technology on that machine, and what they'll do is they'll share the resources without conflicting with one another. So you can have like multiple web servers running on the same machine, or some website which you have, you can have multiple instances of that website, maybe a production website or testing website, something like that. So all of that can be on one machine. You don't have to provision more machines. And then suppose in the future you need more resources for your system that's running on that machine, in that virtualization technology. So the technology allows you to decrease resources on the fly. So you don't have to deploy new machines, migrate all your code to that. So that's like in basic terms, that's what virtualization lets you. It lets you use more resources than are available on the system, because your applications are not using the entire thing all the time. So there are two types of virtualization. One is OS level virtualization, and another is hypervisor virtualization. So what hypervisor virtualization does is it will abstract your hardware. So your operating system, basically it will trick your operating system into thinking that the hardware is the hardware is allocated solely to that operating system. So that is one virtualization, and the other virtualization is OS level, where it's not the hardware that is being virtualized, it's the operating system. So your operating system is tricked into thinking that it's the only OS running on the system, but it's not the hardware that is directly accessible here. So LXC is an OS level virtualization technology. It's called, the full form is Linux containers. So these are, it's a lightweight technology as compared to say hardware like hypervisor technology, where your entire OS is being virtualized. Here what happens is, what it does is basically you'll have one Linux kernel. So how many here have used Linux before? So you know what a kernel is, right? In Linux. So okay, so what happens in OS level virtualization is the host machine will have the kernel installed, okay, and the guest machine. So the host is the operating system that's installed on the server, and the guests are the virtualized operating system that you're installing on the machine. So you can have many guest operating systems on one host operating system. So the kernel is installed on the host operating system, and the guest operating system just reuses that same kernel. It doesn't install its own kernel. It doesn't need to install it, because the host kernel already has all the required features to create the virtualized guest. So LXC uses that technology where the host operating system is already installed, and what you're doing inside the guest is basically you're creating a separate space for the guest. So the guest will be using the host kernel, and it will have its own environment where maybe it will have some different hierarchy, like file system hierarchy, or maybe it will have some different network interfaces attached to it, something like that. So LXC requires a few features to be available in the host kernel, and it uses those features to make those virtualized guests. So so the first feature is namespaces. So how many here have done any kind of programming before? Have you heard of namespaces in programming? Anyone who hasn't heard of that? Okay. So so you can think of it like a football field. Okay, so you have players. You have 11 players in each team. So now each team has a goalkeeper. Each team will have a striker. It will have midfielders. It will have defenders. So the goalkeeper who's defending his goal, it's a different goal that is defending from the other goalkeeper. Right? You have one goalkeeper on one side, another on the other side. Both of them are called goalkeepers only, but they are defending different goal posts. So namespaces are something like that. You have the same type of resource which you're using, but because they are separated by the namespace, that's why they don't conflict with one another.
For isolation.
Yeah. So there are various namespaces. There are 6 namespaces which the kernel provides. It's been almost 10 years that they have been in development. So I think after kernel version 3.8, it was these features were finally available. They started reaching stable state at different points of time, each namespace feature, but after 3.8, I think all of them have reached some point of stability. So you have inter-process communication for communicating between the processes of different namespaces, so so that they can communicate. Then you have UTS. UTS is for if you look at it, the name doesn't actually tell you what it's doing. It's for creating a separate domain name and a host name for your for your guest containers. So that namespace is required for that. Actually, if you look at it, the name comes from the code which is used. Like uname, there's a command called uname on Linux. So it'll tell you the host name and the domain name and everything of your machine. So if you look at the kernel code for it, it uses something called a struct called as UTS name. So that's Unix time sharing system. So it's coming from that. So that is for domain and host name. Then you have mount. If you use Linux, you will know that Linux has a file system hierarchy which starts at root, and everything under and all your other directories under root. So you'll have special directory like /del, which will have all the devices that are attached to your system. Then you'll have other special file system like /proc, so which where you can access all the structures of your kernel and all that. So each Linux operating system will require a root, and it will require a file system hierarchy under that root partition. So the mount namespace allows you to create a root inside your guest operating system. So your host will have a root file system and it will have other folders under it, and the guest will have a separate root file system hierarchy. so they don't clash between the two. PID is to provide separate process identifiers for each of the processes. So on your host you will have something called as init, the init daemon, that's process PID1. In the host also, in the guest also you will have some process called PID1. But if you look at that PID from the host point of view, it will be some unprivileged process. Maybe some process ID like 3, 4, 5, 6 or something like that. But on the guest, it is PID1 and it has root privileges. So that is one namespace that is very important. It allows you to have privileged processes inside your guest, and those same processes are unprivileged outside your guest, so they don't harm your host operating system. Network is to create different network interfaces. So inside your guest, when you create interfaces, they generally are only able to communicate with the host. So suppose you want some remote machine which is not on that same machine to connect with that guest operating system. So you need this namespace so that you can expose the network interfaces of your guest to outside systems and user so that you can have various user IDs and group IDs. So if you look at in Linux, you have each file directory is associated with an owner and a group. So this namespace allows you to separate those from the guest and the host. If you look at if you look at CentOS or some Red Hat based system, then you'll see that it uses something called it has something called SE Linux. It's used to it's a security measure that's in place. So basically it will prevent harm being done from apps which are not which may have been infected by bugs or maybe some malware or something like that. So it's one of those features. So on Ubuntu you will find App Armor. So I know a little bit about App Armor, don't know much about SE Linux. So App Armor will work based on file paths. So a file path, you give it a file path and you say that this file path will only have these capabilities. Only these applications can read to it, write to it, and all. So this. Then the second is this is a security feature again. It's a sandboxing mechanism. So it will sandbox all your guest resources from the host. So anything that's running inside the guest would not affect the host system, and it will allow it allows some sort of transition, like from one secure. It will allow you to transition from one sandbox to another, and it's one of the security measures that are required when you are creating, say, some container, like when you are creating unprivileged processes on the host and you need to move them as privileged processes into the guest. How many of you know about what is a CH root?
Let's begin the question. How much you don't know? That's a very easy one. You find out the how many don't know CH roots? Okay, how many you have Linux background at all or zero? What DevOps have you done till now?
Again, first time.
Oh no, I'm talking about experience in DevOps. You have DevOps experience? Okay. So some of these things, most of the other subjects matters will require you having this knowledge. Okay. So I basically to put this thing in short, the two most important namespaces and that control groups. Okay, these are to isolate your processes from each other when they're working on that containerization technology.
So I talked about this thing, like the file system hierarchy. Have you seen a Linux system where you have root and yeah? So suppose you wanted to create a small directory which would have its own file system, like root and then some directories under it. And you want the application which you are using to think that that directory is the root of that operating system. That process should not move out of that directory. So you use something called a chroot there. You can what it does is basically changes your root mount point, and it tells the process that this is your root. You can't move outside of it. There's nothing outside of it. When actually it's just a folder in your main file system. So LXC uses this chroot kernel capability. So there are certain capabilities which are provided by the kernel, and if you're using a guest operating system on your host, you need to be able to give that container some capabilities or remove some capabilities. So this is provided by the kernel capabilities. If you look online, you will find a lot of information on it. It's slightly advanced stuff. And you have control groups. So this is one of the main technologies that are used by LXC and other container technologies as well. Like I think Docker also requires all this stuff. So what are control groups? So control groups are basically it's a feature that lets you account limit and isolate the resource usage on your machine. So suppose resource usage would be something like suppose you have CPU, memory, and I/O as the resources on your machine, and the guest operating system that are running on it. You want to make sure that they only use certain amount of CPU, only certain amount of memory, only certain amount of I/O bandwidth is allocated to it. And then after you have allocated that, you want to measure how much they are using. Like suppose if you're using it in an enterprise environment, so you need to bill your customers like based on how much they have used. Like Amazon bills based on how much you have used their resources, right? So similarly, C groups will allow you to do that on a machine. Like they'll help you to measure how much resource usage has been how much resources have been used by the containers, and then it will allow you to limit. And main thing that it does is it allows you to isolate those resources. Like the resource allocated to one machine would not conflict with the resources allocated to another guest machine. So LXC is like something like it's chroot on steroids. So it is basically be just a folder on your computer, which will which is like to the guest it's like an entire operating system with its own root and everything, but to the host it's just a simple folder that's running that's there on your machine. And so moving on. These are the main components. There's a library. It has bindings for most of the languages, recorded languages. Then it provides some tools to manage the containers. Most of them use the Python 3 API because the developers are, I guess they are Python fans or something. And you have something called as templates. So we'll look into that. So what are templates? So suppose you want to create a container, and that container should have some operating system, and it should have certain applications installed maybe in it, or you want to provide some different architecture. Like you have a x86 machine and you want to run a ARM-HF architecture on it. Like ARM is the process architecture used on your phones. So templates would allow you to do that. So basically what the template does is you define everything once about what should be there in the container, like maybe the networking and everything, and then you can just reuse that template to create as many containers as you want on your machine. So templates are basically executable files. They could be shell scripts or something else. There's no compulsion there. It should just be able to the LXC tool should just be able to execute them based on certain syntax. most of the templates are stored in that location on your machine. So networking. So this is one of the really good things. Like if you have, say, a container and you want it to be accessible from outside or from a remote machine, you can do it using the networking features provided by LXC. So I've taken an example here. So this is what would be there in your template file. So your LXC uses the interface type VETH, that is Virtual Ethernet. So you define the type there. You tell it that it should be up when the container started. The link. So what is the link? I can show it here. Can you see it? Is it too small? So these are all the interfaces that are there on my current machine. This is the host machine. So you'll have, I have H1 and H0 and H1. Those are two Ethernet links that are there. And then you have something called as LXCBR0. That's actually a bridge, and that is a bridge that is connected to the main interface that is up, that is H0 currently. So what happens inside the container is that when your networking is set up inside the guest operating system, what it does is inside the guest it thinks that it's connected to an Ethernet connection, Ethernet port. But then on the host, what it's doing is it's actually creating a bridge between that Ethernet port inside the guest and your Ethernet port on the host machine. So that's how you get networking from inside the guest. So here you have a link. So that is the link that is between the guest and the host and the hardware address. So if you don't specify a MAC address, it will automatically pick it up, it will auto-generate it. But the downside of that is that every time you start your container, it will get a new IP address and a new MAC. But if you want this to be a public container, then you need to provide a MAC so that every time it will get the same IP. and then the name is the name of the interface inside the guest, and provided that. So the second interface. So now what I've done here is I've set the second type of interface as physical. So the first interface, that is ETH0, it's only able to access the only the host machine is able to access that container, because it gets an IP address which is only available in that host machine. It's not available on the outside. So what you do is you create a interface as PHYS, that is physical, and then you say that the link for this will be ETH1. So if you saw earlier, there's an ETH1 on my host machine. So what this is doing is it will take the ETH1 in the host and it will link it up to the ETH0 inside, the ETH1 inside the guest. So the ETH1 on my host will disappear. I won't see it on my host machine. Now it is inside my guest. So because it's inside my guest and because it's actually an interface on my host machine, it will get an IP address in the range of my network, and I'll be able to access it from that interface. So this is one of the good features where you can access containers from outside the machine.
So if I have multiple guest machines, I can use ETH1 on only one machine?
No, you can use ETH1 on all your guest machines.
So everyone will get different
and everyone will get a different IP. So if you ever check, your one interface can be assigned multiple IPs. So that is what will happen. That ETH1 will get assigned multiple IPs on the host machine, but on the host you won't see that interface because it's already being used up by your guest machines.
Why there are two hardware addresses?
Yeah. So that is the default hardware address that is assigned beforehand. In case this ETH0 is, if in case you don't assign it here. So if you actually start your guest machine and you check, you'll see that only the second one is being assigned. That is the default. That is this is actually the Ubuntu template that is available. I've just modified it a bit. So the default address is always given, just in case hardware, if you don't provide the hardware address for your other interfaces. So if you don't provide it for any interface and it's not set to automatically generate it, next time it will use that hardware address. But on the host, since you already specified one, that C5 will be used for ETH0. Any other queries? So now you've set up your container and suppose you have networking and stuff. But what if you wanted to do some data transfer between the host and the guest? So one of the ways is like directly copying. So like I said, that the container is just a folder on your host machine. So there will be a varlib LXC and the container name, and then there will be a folder called rootfs. So inside that you'll have your entire root bin and dev and all those folders. So you can just copy paste files to that folder and it will be available inside your guest operating system. What if you wanted to access, say, some file system which is only available inside your guest, like a tempfs file system or something that is mounted only when the container is running. So you can use the second command to find out what is there inside that container. Containers run folder. And now suppose there's some folder on your host machine and you want it to be always accessible inside your guest as well. So what you can do is you can add something like this in your fstash, where the first var cache LXC is the folder on your host. The second one is the folder on your guest. Since there is no slash at the beginning of var, it's a path relative to your guest. And it will be mounted what it will do is it will create any missing directory. So this folder will be available inside your guest. So when you create an LXC container, so the file system that by default is assigned to it is none. So what it will do is just use the folder that is there, this folder, that rootfs folder. It just use that and it will just keep writing to it, and it will let the host operating system use whatever file system it's using and let use that itself. But you can also create a separate file system for your guests. Like you can use all these different file systems. The advantage with file systems like ButterFS and ZFS is that, and LVM is that they allow you to create snapshots or subvolumes, and all those things allow you to help you to create backups and all those things in the future. And that is supported. And to create a container, you use the first command. The -t is the template that you're using. So we talked about templates earlier. So the Ubuntu template is by default available on Ubuntu system. So the -n is for the name of your container. So if you saw earlier here, I was writing container name. So here the container name would be U1. And these are some other commands to start the container. LXC, LS would list all the containers running on your system, and some ways to access the container is to use these commands, console, attach, you can use it. And there are some other features as well. So the last command is something called as -g. What you can do is inside your template you can assign a group to your container, and a container can be part of many groups. So using the -g you can give a command to many containers at the same time, the containers which are part of that group. There are some commands. So you can clone containers as well. So instead of creating new containers from the templates, you can just clone them using these commands. So the first command is just cloning U1 template and creating a new one called U4. Now suppose, now this will be good like if suppose you have some production container and you want to do some testing. You just clone it and then do all your testing in the U4 container, and then you can replicate those changes in your production environment. But this cloning might sometimes take time. So what if you only wanted to do the changes on your production itself but not affect your production environment? So what you can do is you can use a second command where it's using the overlay-fs file system. Overlay-fs is basically, what it does is whatever is there at the time of the cloning, root.fs will remain as it is, and all the changes that are there after that will be stored in a separate folder, delta folder, and so it won't affect your main root.fs. So it's just creating a new container in U1 test. It has some other features as well, like snapshotting. So you create a snapshot, it's like a checkpoint of the container at a point of time. So to create the snapshot, the container has to be shut down first. So it's a feature that's highly requested, like to be able to snapshot and clone it while the container is running. Because in production environments you can't stop a container just to take a backup. So still working on these things. So this is how you would take a snapshot. You would the comment that you want for the snapshot, you would put it in a file and then use that to create the snapshot. And the third command will list all the snapshots that are available for a container. The fourth command lets you restore the container to an earlier snapshot. So snap0 is by default the name of the first snapshot. And suppose you wanted to restore to a snapshot, but you didn't want to change the current container. Suppose you want to create a new container from that snapshot. So you can use the last command to do that.
So for cloning, I don't have to shut down the.
Yeah. So no, but it'll actually shut down the container.
It will shut down the container, even cloning.
Because currently I think there's no way to take a snapshot of the running state of the container, like all the processes and the memory and all those things. They're working on it. So it should be available in the next version, probably 1.1 or something.
Is porting a container possible?
Sorry?
Is porting a container possible?
Porting as well.
moving it to some other machine.
So all you have to do is, so I had said that the root FS is on this folder, right? So if you want to port this container to some other machine, all you have to do is copy this entire folder to the other machine, and it will be available there.
How much time is it?
Yeah. How much? Okay.
Because that guy is on 24 hours, right? You don't want to make him leave on night. So you let him start, and then you can continue.
I can take it later. Okay, I'll just see.
Bring in some logical like Alexi. This is Alexi's last.
Yeah, Alexi.
Then
So some ways to contribute to. So there's a development mailing list. There's a mailing list for users, and there's a IRC channel, and these guys are really friendly. So you can contact them. They'll really help you understand what's there and what. There are two main developers. One is Stefan Graber. So he's also a main contributor in Ubuntu. So he's one of the upstream developers. So you can also check out his website. He got an entire 10-part series on using LXC. So it will help you understand. It will help you understand and get up to speed on LXC quickly. The main advantage of LXC is it uses very little resources on your machine. So you can, and if you have like not a really fast laptop, you can create multiple.
Just to give an example, like on mine, if you like taking a Vista machine, 4 GB RAM, you may get maximum one virtual box running. Okay, and with an Alexi, you get at least two working very normal. So that's important. So especially if you look from an Indian perspective, where we are very cost conscious. So anything like a cloud or a virtualized, where you have one guy, two multi, that will sell, right? So,
These are all the machines.
Just to continue with your thought, it will be helpful for our, because I am with government sector, so there also we are having limited scope of funds and everything, so I think that will also help.
oh, what will help you? The money or the?
That is the important aspect.
Yeah, that's everybody's.
These are some containers which were there on my machine. One of the good features of LXC is that doesn't matter what your host Linux operating system is, you can create a different guest operating system on your machine. So U1 and U3 are Ubuntu, but U2 is actually Oracle Linux. So you can create different operating systems. There are a lot of templates which are available. So
You might want to continue later. This guy was waiting.
yeah, I'll just use the last part. Yeah, so these are all the machines which are there on my. I think you can.
Yeah, this video is just. What we'll do is like we still have a salt water, but there's a guy who's actually in US, so and he's 12 o'clock midnight. So we want to give him a chance, and we want to get 12. So we start with that. And
So hi everyone, this is Shaunak. He's developer relations at Rackspace, and his job is to help the community of Rackspace users use the full potential of Rackspace. So he's been working on developer.rackspace.com, right? And he's going to be talking about how they use Ansible over there. So what do you, Sean?
Thanks. I'm going to share my screen. Let me know if you don't see it, or let me know what you see after.
okay, till now, yeah, we can see it.
Yeah, we can see it.
Yes, you can see.
Okay. Are you seeing the web page on there?
Yes.
Okay,
Introducing
perfect. So what you're seeing, well, hi everyone. It's good morning. And so what you're seeing up here is developer.rackspace.com. This is Rackspace's developer website. So this is where users of Rackspace Cloud, who are developers, will come for learning about the APIs or the SDKs that we have, etc., etc. So 3 months ago, we decided to build this site, and being good developer advocates, we said, you know what, we should feel the same pain that our customers are feeling. So we're going to host it on Rackspace. We're going to host this website on Rackspace. So that way we go through all the same issues that any customer on Rackspace would go through. And so naturally, one of the questions that came up was, how do we provision all the infrastructure for this site? It's not a complicated site, but still, how do we provision it? Do we use Chef or Puppet or Ansible? And none of us really had a lot of experience with any of these tools. We had a little bit. None of us are sysadmins. Most of us are developers. So just to give you an idea of why that was the case. And we decided to go with Ansible. And really the main reasons for that, for us, why Ansible was appealing to us was it's agentless. We didn't want to have to set up these machines with agents on them. That wasn't a huge reason, but something that we thought would be interesting to try out. It seemed very easy to understand and use. Like from everything we read, it seemed pretty straightforward. And honestly, a big factor for us was that 2 of the major contributors to Ansible work for Rackspace. And I'll be mentioning their names at the end. So getting help was very convenient. So for all those reasons, we decided to go with Ansible. So I'm going to switch. We should switch to my presentation now. Do you see that?
Yeah. Yes.
Okay, cool. So once again, my name is Shaunak Kashyap, and I'm a developer advocate. So real quick, what my job is to represent developers who use Rackspace Cloud and Rackspace Cloud Services, that is, represent those within the company. So I try to understand how developers are using the cloud and take those requirements or take their pain points to the rest of the company. So I'm really advocating for developers. It's not a legal position or anything, but that's my title. So my presentation today has 3 parts. So first of all, I want to just go over a few lessons we learned from using Ansible to deploy developer.rackspace.com. And then I want to go in the second part. I want to do a live demo. So this may not work, up front, but I want to do a live demo that will show off 2 of Ansible's Rackspace Cloud modules. One module is used to spin up Rackspace servers, and one module is used to spin up load balancers. There are many Rackspace modules for Ansible, but I'm just going to focus on these 2 for this live demo. And then finally, I'll just provide some helpful references that you can maybe take away from this presentation and this meetup. So the first lesson that I wanted to talk about that we learned while working on developer.rackspace.com was that Ansible Vault is really, really awesome. I don't know how many of you are familiar with it already, but I'll just go ahead and mention what it is for those who aren't. So Ansible Vault is a feature of Ansible that allows you to keep encrypted data in source control. So when is this useful? So now let's say you have some configuration data for your application. And by configuration data, I mean your application uses some third-party APIs, and those APIs have some secret keys, and you somehow need to inject those keys into your application so that you can make those API calls. And so where do you store these keys? One option is you could pass it to the application as like environment variable, right? Environment variable.
Yeah.
Okay.
Yeah, please continue.
Alright. So one option is that you can pass these sort of secret variables, secret configuration settings to your application via environment variables. But then you have this issue where you're passing some settings to environment variables, others maybe not. They're not in source control, where the rest of your application code lives. So that's where Vault comes in. Basically the way Vault works, Ansible Vault works, is you take any old any old file, so it could be like a JSON configuration file or a YAML configuration file or whatever, and you encrypt it, and then you can store the encrypted version in source control right alongside your application. So there is a command line utility called Ansible Vault. I think it's Ansible-Vault, and you can use that to encrypt, decrypt, and make changes, etc. So I wanted to show you what that looks like in source control. So this is our production secrets file, encrypted. It's obviously not very readable, so that's the whole point. But it is in source control right alongside all our other code for the site itself. Which brings me to my next point, I guess, that as great as Vault is, it is terrible for collaboration, right? I mean, if I wanted to make a change to this file and submit a pull request, it would look like this. That's what the pull request looks like. I mean, you're looking at before and after. None of my colleagues can really tell that I made a change or if it was a sensible change or anything. So you end up with conversations that look like this, right? I mean, it's not really useful. And so ultimately, it's not impossible, right? You can check out this branch, and my colleague could check out this branch, and then we decrypted the file, looked at it, and it's a little more work, but it's not terrible. I still think the benefits outweigh the costs here. But for collaboration, if you're doing a lot of stuff with Vault, which I don't know why you would be doing a lot of stuff with Vault, but if you are, it is a little bit of a problem. By the way, quick show of hands. I just realized I can see all of you, even though you can't see me. How many of you have used Vault already? Just to get an idea.
Not many guys use Ansible out here. Only one.
Okay. One. Okay. So this is somewhat reasonably useful. Okay. All right. The next lesson that we learned was to reuse Ansible roles. So let me have another show of hands. How many of you guys here are familiar with what a role is in Ansible terminology?
One or two.
Okay, so I'll just recap real quick. You guys are probably already familiar with it, maybe just don't call it that. So role is kind of like a recipe for setting up a specific part of your infrastructure. So for example, you may have a front-end web server role, or a API server role, or a worker node role, something like that. And what it is really a role is just a collection of tasks saying do this, do this, do this, then do this, and so on. So it turns out that this definition of a role actually makes it very convenient for sharing and reuse. So what I mean by that is, so let's say you wanted to set up a web server running Nginx. And you could create a web server role that downloads Nginx, installs it, configures it, and then restarts the Nginx service. But all of these tasks are very generic. Like anything that uses Nginx is going to have to do these tasks. So what if you could just use someone else's roles that someone had created for Nginx, and that way you could just take that role as is and plug it into the rest of your Ansible setup, and maybe with a little bit of parameter passing to that role, you could get it working for yourself. So that's really how role is really the unit of reuse in Ansible. And at this point, I should probably mention Ansible Galaxy. So Ansible Galaxy, I'm pulling it up over here. Ansible Galaxy is kind of the repository for reusable Ansible roles. So if you go to, I'll do a quick search. If I go to browse roles, and if I search for Nginx, I guess I already had searched for it, so it's already populated. You can see that there are all these roles that people have created for Nginx. So there's quite a few. I'm just going to choose the second one because it has this 4.0 community score, so maybe it's good. And it tells you exactly how to install it, what are the variables that you can set and sort of pass to the role, etc. There are examples and whatnot. So this is where you would find roles, and then the installation is how you would pull them into your own Ansible setup. So this way you don't have to define what it means to set up Nginx every single time or for every single project. You can just sort of reuse this role. And there are many other roles for many other things as well. So that's something we learned. Let me show you our repo again. This is our this is the repository for developer.rackspace.com, and you can see that the first two folders here are actually Git submodules. So that's how we decided to pull in these Ansible roles, was by making them submodules of our Git repo. So that way, anytime we check out our repo and we do a Git submodule in it, have to have an update, we also pull in the Ansible roles from their respective repositories.
Shona, can you just zoom into the area where the repository names are? It's not too readable.
Oh, I'm sorry, what?
The repo area, just can you increase the zoom into that? The names are not readable. Yeah, thank you.
Okay. Is that better?
Yes.
Okay, cool. Thank you. Thanks for letting me know. So yeah, the first two folders, hopefully you can see them now, they're actually Git submodules, and they refer to the repositories for those respective roles that I found on Ansible Galaxy. The next, I guess the final lesson I want to talk about that we learned was kind of just contribute back to Ansible. So Ansible is open source, and many of these roles, or possibly all of them, are also open source. So I'll give a real example of why, like when we had to do this. So let's go back to the Nginx role that we were looking at here. And as it turns out, this role will put your configuration file. So when you define a configuration file for a particular server or in Apache terms for a particular virtual host, Nginx will, you can put it under etc Nginx sites enabled, and I'm sorry, sites available, or you can put it under etc Nginx conf.d. So this role puts it under etc Nginx conf.d, and that's, that doesn't seem like the right place because there is a separate, sites enabled directory or sites available directory for all website configurations. So minor change. So what we did was, I submitted a pull request, and I believe it is over here somewhere, my pull request to, so this is my pull request to that, better join Nginx for, basically making the change that I wanted. And, as you can see, I'm saying that instead of putting it in etc Nginx conf.d, put it in etc Nginx sites enabled and symlink it. So that's one way of contributing to Ansible, and one reason to contribute back to Ansible is if you don't like something, right? I mean, this is true of any open source project, not just Ansible. The other way you can contribute is by writing Ansible modules. So later in this presentation, I will demonstrate as I said, two Rackspace cloud modules for Ansible. But when we were building developer.rackspace.com, we wanted to have monitoring on our infrastructure. And as it turns out, there is no Ansible cloud module there is no Ansible module for Rackspace cloud monitoring. So we wrote one, and we wrote one and we submitted a pull request to, as you can see, in this case, it's to the core of Ansible. And this is basically to enable cloud monitoring, Rackspace cloud monitoring in Ansible. So that's another way you can contribute back to Ansible. And that was it was a pretty good lesson for us because we were able to get going right away, but then we also realized, somebody else might care about the same stuff. So there. Next, I want to do the live demo, and so I'm going to switch screens a little bit here between terminal and browser. And let's see. So for my live demo, I'm just going to set up a very, very simple website with 2 web servers and 1 load balancer, so nothing fancy here. And each web server will just run Nginx and PHP. And it will have a simple PHP script that says I am web server 1 or I am web server 2, that's all. It just queries its own host name, that's all. But via this demo, I can demonstrate the use of Racks and the Racks CLB modules. The Racks module is used to spin up servers, and the Racks CLB module is used to spin up load balancers. So let me switch to so the way I'm going to go about this is I will kick off the demo, and then we will deep dive into the Ansible playbook itself and go through the 2 modules, like where I'm using the 2 modules, and we'll look at what parameters they take, etc., while the demo is running. And then hopefully the demo works and we can actually just visit the site, and if we hit the load balancer IP, we should see it saying I'm web server 1, and then if I refresh it, it's a web server 2, and so on. That's pretty straightforward. So let me switch to oh, sorry. Okay, let me switch to the terminal here real quick.
Just 1 minute, Shonak. I think so. Yeah, we just got timed out.
Alright?
Just 1 minute. The screen got locked out because of timeout. Yeah, okay, Johan.
Okay, so I'm just about to kick off the demo from the terminal, so just give me 1 second. Here we go. So do you see the terminal now?
No. Yes.
Okay, is the font big enough or no?
Slightly bigger would be better.
Yeah, okay.
Yeah, this is good.
Okay. Let me just resize the window.
Uh,
Okay. So
and could you just move your window slightly lower in the screen?
okay. No
Because on
problem.
the top you have those Google. No, I think it's
Oh.
our end. So you can.
It is our end. You have to full screen this.
No, because you have that Google logo and everything on the top. So could you just
Oh,
move?
yeah, I know what you're talking about. It's the Hangout logo, right?
Yeah.
Um,
I think
is
it's.
that better?
Okay, you're sharing your window, right? Not the desktop, right?
Yeah, I'll just put some new lines over there.
Yes.
Is that better?
Yes.
Okay. So, alright. So before I actually kick off the demo here, let me prove to you that I'm not cheating, that I'm actually starting from scratch here. So let me go to my Rackspace Cloud account in the browser, just the control panel, and show you that there is nothing already there.
You have to share your browser.
Yeah. So I'm just going to use my personal account over here, and so this is a Rackspace Cloud Control Panel, and I'm on the servers section. So as you can see, there are no servers in the Dallas region or DFW region of Rackspace, and similarly, there are no load balancers either. So it is a completely blank setup. That said, I will list out some prerequisites that I had to set up, sort of one-time setup things, so that you're aware of those. So the things I had to install, obviously I had to install Ansible on my computer. I had to install something called Pyrax. So Pyrax is a Python library to talk to the Rackspace Cloud, and Ansible will use Pyrax to talk to the Rackspace Cloud. So I had to install Ansible, I had to install Pyrax. I had to create a credentials file on my computer with my Rackspace Cloud username and API key. And then finally I had to upload my SSH public key to my Rackspace Cloud account, so that way when Ansible needs to SSH to the server and configure it can use SSH like a key pair. So those are the things. Those are all one-time set of things that you will do. The first time you use Ansible with Rackspace. Once you do that, then the rest of it. That's all the setup I've done. The rest of it we can walk through here. So this is. Let me share my terminal again, and we'll kick off the demo. Okay. So this is the command to actually kick off the Ansible playbook. So the first thing that you see there, racks_regions equals DFW, is the region that I want to use for spinning up all my infrastructure. Then it's the Ansible playbook command itself. Then I tell it where the inventory folder is, and we'll look at that, what's in that folder in a second. And then finally I tell it the playbook that I want to run. And so I'm going to go ahead and kick this off. And while just make sure it's running okay. So it started running here. As you can see, it says provisioning web servers. So now if I go back to my web browser and go to the go back to my cloud control panel, I should see 2 web servers being created. And as you can see, there are 2 web servers that are being built right now. So while that demo is running, let's dive into the actual playbook and look at the code here. So this is the folder, and the first folder here I want to talk about is inventory. So inventory is usually how you will tell Ansible where you want to deploy, or what servers or whatever infrastructure you want to work with, you want Ansible to work with. And typically that is specified in like a single file, like a hosts file. But in this case, because Ansible is talking to Pyrax, and Pyrax is in turn talking to Rackspace Cloud, and Pyrax is installed locally, I just need Ansible to talk to the local host. That's why that's all my hosts file under inventory has in it. But if there's another file called racks.py. So this is something called dynamic inventory. So the reason we need this is when you're dealing with the cloud infrastructure, you don't know the IP addresses or host names of your inventory of your infrastructure ahead of time, but because they keep changing. So what this racks.py file will do is it will query your cloud account, and it will pull down an inventory of all the infrastructure that is there and organize it for you into groups. So like you might have a group for web servers, and it'll put let's say 2 web servers in that group and so on. So that way Ansible can dynamically query your cloud account and form sort of this inventory using this racks.py script. And by the way, this Ansible supplies this script, so you don't have to write it or anything or grab it. It comes with Ansible. So that's dynamic inventory. Let me make sure my demo is still running. It looks like it is. Okay. So the next thing to look at is the actual site.yml playbook itself, and we'll just go through it fairly quickly because I think we might be running out of time. So my site.yml playbook has 4 plays in it. Provision web servers, configure web servers, provision the load balancer, and configure the load balancer. And so let's go through each of these plays. So a play can consist of 1 or more tasks. So provision web servers would be, create the web server in Rackspace Cloud. That might be a task in there. So if you look at this, in my 4 plays, there are no tasks in here in line. Because what you can also do is move the tasks to a role and then just include the role from the play. And that's how I prefer to do things, and that's how I think Ansible, if you look at like the best practices also, they say your playbook should contain plays, and plays should refer to roles. And the roles should be the ones that actually contain the tasks. So I'm going to go through each of these roles. So there's a folder called roles in this directory, and if I open that up, that has a web server provision folder, which is the same name as the first role over there in the playbook, and that has a task/main.yaml file. So this is what that looks like. So the first thing to notice is this racks module over here. So that's the module used to spin up Rackspace Cloud servers, and it needs to know your cloud credentials, like your username and API key, and those are stored in this file. So you're just telling the module where to get them from. You need to tell it how you want to name your web servers. You need to tell it how powerful you want them to be, how much RAM, CPUs. Rackspace calls that combination of flavor. You need to tell it what image, so basically what operating system you want, what networks you want to enable on this cloud server, the region like Dallas or Chicago or whatever region that Rackspace is in. Then Ansible is declarative, so you tell it what the state of things should be when it's done. So you say, I want these servers to be present. So that means if they're already there, don't recreate them. This is what makes this task over here idempotent. And then I'm saying I want 2 of these servers, and I want exactly 2. And this one is somewhat interesting, this parameter, which is I want you to group them as web servers, so that later on, if I refer to web servers, you know which two exact servers I'm talking about. The wait just says wait for this task to complete before doing anything else, and use this SSH, or inject this SSH public key. If you remember, I had a SSH public key uploaded to my Rackspace Cloud account called mine. So I'm just saying inject that one into these servers so I can use it later to connect. And finally, the register property here says that whatever the output of this task, capture it in the Racks web servers variable, which I will use later. So, and the next task in this role is to add these web servers to a host group, which is also called web servers. So it's a little confusing that I'm calling, I have a group called web servers in the earlier task, and I have a group name which is also called web servers in the later second task. This is intentional, so this is a little bit confusing. So if you run this playbook for the very first time, the first task will create two web servers, and the second task will run, because as you can see in the second task at the very bottom, it says when racks underscore web servers are action equals create. So the second task will only run when the first. Hello?
Yeah. Yeah, you can continue.
Okay, thanks. So the second task will only run when the first task has created web servers. And so that happens when you run this playbook for the very first time. But let's say you ran the playbook again. Those web servers already exist, so you don't want to recreate them.
Yeah.
Which means that, and the first task will run, but because we already have two web servers, it won't create any more. And so the second task will not run. So what we need is a way to, one way or another, we need this web servers group to contain the two web servers. The two web servers that have either been created or already exist. And that's why there is some repetition here, depending on whether you're running this playbook the first time or subsequent times. So this row over here that you see on the right configures the provisions the web servers, just creates them. The next role is to configure them, and this one is not Rackspace specific. Nothing in this is Rackspace specific, so I'll go through this one really fast. So in this role, all I'm doing is installing Nginx PHP, creating the document root, throwing that PHP file in there, that one-line PHP file, and restarting Nginx. So that's all I'm doing in this configure web server role. And the next role that we want to look at is load balancer provision. So in this case, in this role, we're using the racks_CLB module, and that's the module you will use to spin up a load balancer on Rackspace. So again, it needs to know your Rackspace cloud credentials. You want to give the load balancer name, which port it listens on, protocol. I wanted to do a round-robin load balancing between my load balancer nodes. There's the region, again, same as before. Wait, again, same as before, and I want it to be present. And once again, I capture the output of this task in the Racks load balancer variable, which I'll use later. The final role over here is load balancer configure. And this uses a third module, actually, called Racks CLB nodes. And what that does is adds nodes to a load balancer. So in this case, once again, it needs the credentials, so it knows how to talk to the cloud. It needs the load balancer ID. So internally, Rackspace has these numeric IDs for load balancers. So we just want to grab that ID from the load balancer that was just created. And that's where we use this sort of lookup over here. So I'm looking up against this Racks load balancer variable, which was, if you remember, registered in the previous role. Then I want to add the servers, the IP addresses of the servers. I want to tell the load balancer about them so it can attach them as nodes. So you notice this with items at the bottom, towards the bottom. There's this with items property, and what that does is it will loop over as many web servers that are, loop over them and run this task. So it's going to add each of the web servers' private IP address to the load balancer as a node. then I'm saying that each of these web servers is running on port 8000, and that's how I've configured Nginx, so I know that to be true. I want them to start out enabled, so whenever the web servers are added to the load balancer, I want them to start out enabled, not disabled. And Rackspace has a notion of primary and secondary nodes for load balancer. So primary are, I won't go into the detail, but basically secondary is like a failover set of nodes. So I want to say that the nodes I'm adding right now are all primary. And then wait for this to complete and the region in which I want to set this up. So that's basically, that's the last row. And at this point, we should have 2 web servers spun up, configured with Nginx, PHP, etc. A load balancer spun up and attached to those 2 web servers. So those are the things that should have happened. So let's see if our demo completed. And it looks like it may not have completed. Well, let's see. I see some errors here, but let's see what happens. What it looks like in the Rackspace Cloud Control Panel. So switching to this, I see that these 2 were created okay. Let me go to the load balancers and see what's going on here. Okay, looks all right. Let's test it. So if I go to the load balancer's IP, and if I hit it, so something did go wrong here. It looks like one of the web servers, web 1, it got provisioned correctly, but did not get configured correctly, and that's failure was on the terminal. So I don't have, this is the risk of live demos, I guess, and I don't have time to debug it right now, but yeah, so things can get messed up, I guess, is the moral of the story. Let's see. So let me switch to the terminal real quick just to look at the Ansible output. So the way I knew something was messed up is it says it's unreachable, so this looks like some kind of network issue here. So what it looks like it only partially provisioned the web server properly, but probably couldn't reach it afterwards to configure it, and that's why the load balancer is only able to get to one of them. Okay, so I'm not going to debug this right now, so otherwise it'll take up a lot more time. So moving on, let me see, what are you guys seeing right now, my browser? No, you're seeing my terminal, okay. Let me switch back to the presentation. Okay, so the last thing I just want to talk about and I'll leave it over here is some references. So, as I said, about 3 months ago, most of us on the team barely knew what Ansible was, and we couldn't have done it without a lot of help. We couldn't have got to running production infrastructure with Ansible without help. So one of the places I found really helpful was this Google group for Ansible. I highly recommend it. I discovered Ansible Galaxy and I figured out what role I wanted to use for Nginx, but I didn't know what the best way of incorporating that into our setup was. And I got a couple of different suggestions from this Google group. So it's pretty active, people are pretty responsive, so highly recommend that. The next 2 people that you see on this list, Jesse Keating and Matt Marks, they actually work at this, but they are also, as I mentioned earlier, they're contributors to Ansible core, as well as they have written some of the Rackspace modules for Ansible. So they're both very friendly people. You can contact them on Twitter or whatever if you need any help. So that's some useful resources. And then finally, the website that I've been talking about, developer.rackspace.com, the one I showed earlier, you can go check it out. It has a lot of useful stuff if you're interested in using the Rackspace Cloud as a developer. And we have open source the actual code for that website. I mean, we work in the open for most things, so you can go to that GitHub repo and you'll see the code for our website. Then today, and that includes all the Ansible setup. So let me just, if you go to racketlab/developer.rackspace.com, and then the deploy folder has all our Ansible inventory, roles, etc. All of that is over here. So you're welcome to poke around and explore. And then today's live demo this over here, it's obviously very simple, but you'll see the playbook and the roles and the inventory, everything that we were looking at. The README file will explain exactly what's in much more detail than I talked about. What you need, like what you need to install and set up, and all the prerequisites that I already had set up. It will explain all of that over here, and then finally how to actually run the demo. It also has a folder for cloud presentations, and this is actually the presentation that I'm showing, so you can even look at these slides over there. And then the last thing is just, if you want to get in touch with me, these are a couple of different ways to do that. So thank you very much. That's all I have. Thank you for doing a hangout with me from here. Appreciate it.
Hey, thanks, Sean.
Thanks, Sean.
Okay. Anyone has any queries for Shauna?
So I had one query.
Yeah, go ahead.
So about the Volt, you said Volt is a very good concept. So
Can you hear us, Shona?
Yeah.
Okay.
yeah, so on the Volt, when the comparison with other agent-based technologies and agentless technology comes into picture, what are the security? How would you comment on the security aspect of this? Because now all my keys are present in the Volt, but I will need a key to the Volt itself, so that only I can download it. So how do we answer that?
Sure. So the way that works is when you let me pull up. Let me do another quick screen share here and pull up a website that will explain that a little bit. So Ansible Vault will, as you pointed out, you will need a key to encrypt it, right? So it will prompt you for the key when you create the file, and then when you run the playbook, there is this parameter that you pass in that will prompt for the that says, okay, prompt me for a vault password. So and then what it will do, as it says over here, it will decrypt it, keep it only in memory, and it will deploy the decrypted files, via SSH onto your wherever your target hosts are. So that's how it works. The decryption, the decrypted content is never written to disk until it reaches the target host, basically. And that's as far as I feel comfortable commenting on it. I'm not familiar with how other based technologies do it, so I really couldn't speak to if one is better than the other security wise.
Okay. So when you pass this parameter, you have to type the password. Is a person
That's
required
right.
then? Okay.
Yeah, you have to type it, so yeah, it's interactive and it's obviously hidden, etc. But there is a way to make it non-interactive. So you can give it a file as well with the password. So if you're doing something via Jenkins or something like that, you have to get CD going on or something. There is a way to do that. So, but at some point you're going to have to type it.
Yeah.
Right? At least how do you create this file? So at some point you're going to have to, the first time or whatever. So yeah.
Okay. Okay. Thanks.
Any other questions? Okay.
Okay, thank you. Have a good night. Thanks.
Alright, thanks. I'm going to sign off. It's 1:45 a.m. here, so I'm going to go to bed now. But thanks again, everyone. I'm hoping to be down there in December, so maybe I'll come, swing by in December and see you guys all in person.
Yeah, sure. Try to make it last week. We'll have our sessions.
Okay.
Thanks. Bye.
Alright, bye.
Bye.
Okay, so good afternoon. So we have half an hour for this, and it's before lunchtime, so I'll make it quick. I think Shaunak also touched upon some of the key perspectives of roles and provisioning, things like that, so I think we should be able to move quickly. So myself, my name is Sanju Burkule. I run this company, OPEX Software. Mainly it's on cloud automation. For cloud automation, we use all these technologies, Chef, Puppet, Ansible. So today I'm going to focus on Chef, mainly because we are partners of Chef. With Chef, when we want to do some big data related things, we use Hadoop from Hortonworks. So we do all the provisioning with mainly dev environments. We do with DigitalOcean, Cloud or Linode, and production environments with AWS.
Why do you make that distinction?
Because AWS is costly. AWS is costly. DigitalOcean is quite cheap. And I love the UI of the droplets, and I like it. Yeah. So this is a very short session, half an hour session. I'll just give you a glimpse into Chef. I'll use the same material that we use in Chef Fundamentals course. But if you want full trainings, we have them. Because we are partners of Chef, we do this all over India, Delhi, Pune, Bangalore, Chennai, Hyderabad. The Pune one is coming up on 12th and 13th of August. So first, before we get into what Chef fundamentals are, I'll tell you the business use case of where we generally use it. So main thing is software is deployment automation, or for doing patching, any redundant activities that you do on a lot of servers. So this we connect it to some help desk management system, like Remedy help desk. So before that, my background is I'm from BMC Software. I worked there for 10 years before I started this company. So BMC Software has this GridLogic automation, which is another product in data center automation space. So competitor for that is Chef and Puppet mainly. So BMC has this product called Remedy, and from IBM we have Tivoli Service Desk Management, and then you see lots of tickets coming in every week. You get similar kinds of tickets like changing passwords, getting Oracle boxes for the people. So those kinds of similar tickets that you get, you can automate them using softwares like Chef and Puppet. Okay. So you may want to deploy a new box and deploy software on it. You may want to do patching on it. You may want to do configuration automation. All these basic tasks, and some advanced tasks like even PCI V2 compliance, HIPAA compliance for hospital industries. These kinds of things which you want to do on large amount of servers. This you can do very successfully and nicely with this tool. So this is the integration that we do. Okay. It is very valuable to have this kind of a knowledge. I have seen people's careers really go up because of this. So now coming to Chef. So you saw one use case there. I covered the DevOps use case in the last 10 minutes. Okay. The main thing why I like Chef is because the concept says infrastructure as code. So how many people don't know infrastructure as code? Okay. So coding generally, so I have all developer background, C++, Java kind of background. So with coding you use the source code control systems like Git or Visual SourceSafe or some of these things. The awesome thing about Chef is they imagine the infrastructure that you can create lots of servers, network devices, and the connection between these servers as code, and that which means you can source code control these things. I can go back to yesterday's environment whenever I want. I can go back to last week's environment whenever I want. I can provision all those boxes with that configuration. So generally when you go to companies, large companies, and let's say network is slow, the IT admin asks one question. He says, what changed? What changed yesterday night? Yesterday everything was working, now what changed? And then you spend 4-5 hours figuring out what exactly is the difference between what was running yesterday successfully and today. So instead of doing that, you can go to yesterday's version of the configuration within a minute. It may be a few more minutes, but you can get those. You can get to the state of yesterday's infrastructure because everything is stored as code. And that vision itself, I find it extremely beautiful. That's why I went deep into Chef. And so mainly what Chef is, it's a configuration management system. Okay, it integrates different parts of your system together, and I'll show you how that works in DevOps. It's an API for your entire infrastructure. There are REST APIs available, so you can make a lot of calls and make things happen via Chef. And it's open source. You can see the source code. You can contribute back to it, much like Ansible and other tools. So Chef's real value is in this collection of cookbooks, just like the Ansible Galaxy. these cookbooks, there are 1000 plus cookbooks available. For Puppet, you have 2000 plus cookbooks. For Ansible, I have to see how much there are. But these are good quality cookbooks written by the best sysadmins, and we depend on them heavily. So this is the most important value of Chef. The rest of Chef is basic, simple client-server application. There is nothing really rocket science about it. It's a client-server application, but these cookbooks makes it extremely valuable. I'll show you the basic architecture. So you have a Chef server. This can be on your premise or it can be hosted Chef. And then you have your nodes, you have your environments, you have dev environment, QA environment, production environment, pre-prod environments. And inside each, you can have nodes. And in each node, to call that server the part of this environment, there are some attributes. You can say that for this node object, it belongs to a dev environment. And that provision is made by Chef, the Chef application. When it is collecting the inventory information of your entire system, it collects all the attributes of it. And I'll show you some of the attributes it collects from each of these nodes. And it saves it in the database of a Chef server. So that's how it basically interacts. There is a database here of your entire inventory, and you can search that database. Simple queries, using simple queries, you can ask how many web servers do you have. In the previous example, you saw how many web servers do we have in Ansible, correct? Because Ansible, they created a web server group. Shauna created a web server group in that. So same query you can fire on the database over here, and that makes Chef extremely powerful, because now what you can do is you can do something called as elastic infrastructure management. And I'll show you some of the diagrams of that from the Chef fundamental slide to really get the value of it. Okay, technically it is simple, but the value is very high when it comes to real life applications. Any questions till now? We are going to call these things as nodes. Okay, that's the Chef server. It can be hosted Chef, it can be on-premise Chef. Okay. And the roles, the definition of role is exactly the same as in Ansible. Role is basically, you can call a set of boxes as web servers, where there are some certain web application related, Tomcat, Apache related binaries present. So you can say these are web servers, these are database servers. So that is basically a role in most of these languages. Okay. In every role you have something called as run list on what do you want to run on each node. You can say that these 5 things represent web service, and you can say this is the run list for making a particular node a web service. These are my Oracle binaries. This will make something as a database server. Okay. So what you want to run on each of these nodes is called a run list, and all these run lists, some of these recipes on what exactly you want to run on each node, when you put those recipes together, it's called a cookbook. And you will remember this once I show you some pictures, and I talk about scalability of Chef after that. Let me go to Chef. I'm going to jump on some of these slides because the slide quality is very good in the Chef fundamentals. Okay, this is the direct training course fundamentals PDF from Chef themselves. Since we are partners of Chef, we have some better quality diagrams that we can take a look at. So these are the main concepts required for doing infrastructure management. Node, the resources, what you want to manage. Recipes is exactly what you want to do on each of these nodes or a group of these nodes. Cookbook is a collection of recipes. Okay, run list is the sequence of cookbooks or sequence of recipes you want to run on a bunch of nodes. Roles is a logical entity, how you look at your infrastructure. Okay. Search gives you a great advantage of how to bring dynamism into your infrastructure management. And let's go through this. So these next 6 slides are really nice and beautiful. Now basically managing your applications, business applications which have to be up and running, right? Along with these basic groups that we talked about, there are something called as packages that everybody has to install. There are some tasks you have to do on packages which are day-to-day operations. Services have to be brought up and down, which is basically the configuration management, day-to-day configuration management that we have to manage. These 7 to 8 main groups, once you get hang of how to manage this using these configuration management tools, then it makes you really very powerful, because you are managing huge amount of servers through some commands over there. Okay. So these resources have to act in a concert together. You have to orchestrate all of these to really provide some valuable service to the business. And the infrastructure keeps on evolving as the business keeps on expanding or shrinking. So you start with a node, then you put a database below that. Now once the application grows, the data grows, you put 2 databases, you have 2 app servers, then you have the infrastructure goes on increasing. Now you need a load balancer, a cache in between, and all these are configured together to work. So each of these has a configuration file .conf, and that has information about all these IP addresses. And that's the same conf file we also changed from the Ansible configuration playbook, right? So this same conf file has there is a different way of managing it over here in Chef. So once the configuration, once the complexity increases to such a large extent, then it really doesn't, a junior person cannot do work any longer on these kinds of applications, because now you need senior people to understand how many read databases are there, how many slaves are present, and then you have multiple data centers where the databases are replicated across sites. So then to make things still manageable, you require tools like Chef, which I'll show you in a second. How it actually does it, because there are lots of slides here. I'm just going to focus on key source codes which can make it really, which can give you the impact of how it really does the work. Okay. So what you're basically managing is you're running exactly the role on the node. You're reducing the complexity of management, and you're managing all the versions of each node in version control system. These are 3 basic concepts for every program. And the way you do it is, you are defining policies. You are saying what you want to do. You are not explaining how you want to do. Like general automation programs, they explain what you want to do in various steps. Through Chef, it's a declarative language. In declarative languages, what you say is, this is how you want the state of each server to be. Once you declare that state, Chef will check each and every attribute of applications or conf files, the values of conf files, and if those attributes do not match, it is going to make those changes there. To give you an example, there is this travel website which used to go down every 2-3 days. Now people did not know exactly why it was going down, so people had to spend a few hours debugging it. Sometimes the service itself was down, sometimes the port had changed, sometimes different access rights was given to different people. So these kinds of debugging, you don't need to do it when you are managing things through Chef. What it does is every half an hour, a Chef client runs on the node. That Chef client on the node, it contacts the server and asks, how should my configuration be? And if the server says that you need to have these users on your machine running, you need to have this service up and running all the time, the Chef client will just make sure that that service is up and running. Okay. So let's say on the travel website, if you go and directly change something on the server, the Chef client after half an hour when it runs, it will again check if the service is down, it will make it up. So without logging a ticket, 712 ticket, and then somebody working on it, and then figuring out the problem, it checks the configuration every half an hour. And you can change the half an hour to maybe 5-10 minutes. But this is something called as configuration compliance or configuration assurance. You're assured a particular configuration, whatever is defined in your Chef server. This is the single most powerful thing that saves huge amount of time for many companies. Very basic thing, but there is no need of manual intervention for these kinds of activities. Okay. Next important thing is it is pull and not a push. So this is a huge difference between agent-based technologies and agentless technologies. Okay. A pull is the node is pulling the configuration from the server. The node is asking the server, what is my role? Am I a database server? Am I a web server? What should I exactly do? How do you want me to get configured? So when the node is making a request from inside the infrastructure to the server, it's a very secure request because it is making the call from inside the company. Okay. If it's an agentless technology, you need access to all the machines from outside, and when you're making that kind of a call from outside, then you require that kind of a contact and all the information on how to contact these machines. So this is one of the major questions our customers ask on should we go for agent-based technologies or agentless technologies. So if it's a pull, people feel slightly more secure.
That is if the server is hosted somewhere else, outside the company's ED or whatever.
Yeah.
ED policy and all that.
Yes. If the server is hosted inside, then there is no question whether it's pull or push doesn't make that much of a difference because it's in the still controlled environment. So once again, just to talk about Chef infrastructure as code, you are programmatically provisioning machines and then configuring them. For provisioning machines in the latest Chef version 12, there is a new construct called as Chef Metal. So there is something called as a machine, a new construct that is called a machine construct. Using that machine construct, you can create a logical machine and say what you want it to be, and then create it on any cloud. So, so that is really helping Chef to really grow fast. Earlier they were having some partnerships with some other provisioning components. It also used Vagrant for some of the dev related work. But the machine construct, the machine resource is now very, it's taken up in an extremely huge way in many companies. Okay, it provides you ability to create a data center definition, and you can move it to any cloud of your choice. So tomorrow Linode today is now 30% cheaper than AWS. So you can move your infrastructure there. If you have everything automated using Chef and defined in a cloud agnostic manner, if you're not using any of those AWS sticky concepts. Specifics. Okay. So this is very powerful.
I mean, does it help like running migration? How do
Yeah, running migration, live migrations. We have demos where from AWS, a running web server, you can move to Azure live.
The only servers are not the data. I'm not sure. How
Data has to be
data migration
replicated.
is a different beast only.
Yeah. So I'll show you that data part of it in the DevOps last column. I'm just zooming through because a lot of this is going to be repetition for the entire afternoon for all these concepts. It's same provisioning configuration.
Yes.
Roles is also the same. So after a couple of hours, I think it will be very clear. But provisioning has become extremely strong in Chef through that Chef Metal kind of concept. Configuring I already explained, and it is you can treat infrastructure like any other code base. Even though you're creating machines, creating data centers, but you can treat it like any other source code base. And this, I just love this statement. Okay. Now, so this is an example of how a recipe looks like. This is a very basic, simple recipe. It has 3 simple constructs: a package, something that you want to install, some binaries that you want to install. Once something is installed, you have to start that service. So this is an NTP example where you are installing the NTP package and you are starting the NTP service. And then you want to make some changes in the configuration for the NTP configuration file. So you give the permissions for the configuration file, and then you tell exactly what you want to do with it, and then you start the service. So anytime a configuration changes, it will start the service because you have a notifies call. So you can, from each of these resources, you can trigger any other resource which is dependent on it. So the order of your installation, like creating users, then giving access to them, creating a group, adding a user to that group. So many of these things have a sequence. So you would like to have a construct which where there is a connection between one resource and the other. So that is the notifies call over here. But otherwise, most of the applications, many recipes have only these three constructs: a package on what you want to install, the services that you want to start in a particular sequence, and the configuration files, which are templates. These ERB files are templates, and the entire code is Ruby based. Okay, it's pure Ruby. If you know Ruby, then you have an advantage in for starting in Shell. Any questions up till now?
One question. Little deep. When you have to modify a particular config file, I just want to modify it half. So how do you do that in this? Because
So-
I generally what I do is I take the complete I copy it completely and then I push it. I mean, I save a complete configuration. I don't do a partial change. How do you do a partial change?
So partial change. So if you want to change only one attribute of a configuration file, since this is idempotent, so it will make only that change. You have to run this. Once you run this recipe once again, it will check that here there is no change. It's already installed. Package is already installed. Here it will check that okay, this configuration has changes in 2-3 areas only. It will make only those changes. It will not make the entire change, full change once again. So this is one way of doing it. Second is there are programs. I forgot the name of the software, but I think it's NGS or AGS or something like that. That particular software allows you to make only partial change to a lot of different configuration files. And I'll send you the name of that exact software. It is somewhere in this huge slide deck. But let's say there is a huge file and you want to search for something and you want to make a very small specific change in 2 or 3 locations. So you make that in your temporary file, and the code that you write, that code you push to all the servers. So it will just make that much change. So this is demoed in the Chef Conf 2013 August on how to make a small change to a lot of files.
And that's actually one of the most requirements in DevOps. You make that, especially more less of provisioning. When you get a lot of service, more that DNS, those kind of big things, you know, and on a whole scale as you go.
Yeah. See, because provisioning, these are just your initial things, right? That we call as day one operation. But to keep the application running, that's the real operation that is the that really earns us money as well. And
there's a lot of work. I mean, that's total cost of ownership. That will be a lot of ownership, you know, across the days.
So this is another example of NetSNMP, how to install a NetSNMP. Here also you can see there are the same three constructs: the package, the service to start with NetSNMP, and the SNMPD configuration file. If you want to install Nagios, it is very similar to this. Just the configuration file for Nagios looks very big on exactly which parameters you want to monitor, CPU, memory, and those kinds of things. So OHI. So OHI is a inventory, is a discovery tool which will go and discover your entire infrastructure, and for each node it creates a file something like this. For each node, it tells how many network, what is the information about your network. Okay, it will find out the name of your server, the FQDN. It will give you the number of buffers, the amount of buffer you have, the free space you have. Where is the kernel version? The kernel version somewhere. It will give you all the basic information of your operating system, kernel versions. So this information collected for every node and network devices also, switches, routers. It collects that information as well. All that is stored in the server side, the database of the server side. Now once you have that, you can do a lot of inventory management exercises. So if your company has any asset management questions or how many Windows licenses you have, you can make a query and you can get that answer. So this was one of the major things on asset management route to values, which BMC sold for 2-3 years, multi-million-dollar deals, just to find out what do I have in my entire infrastructure across the continents. So just for that simple reason, BMC created a set of discovery tools. So that comes for free with open source technology. So OHA is a good tool for that.
And this is part of Oxford, I mean.
Yeah, that's part of Oxford product. You will get it when you install the Chef client on the node. It comes as part of it. And the Chef client will collect all this information and send it to the server. So this is called OHI. This I'll skip. Now this is Ruby. Since this is Ruby, you have these loops, and in every loop you can go to every server and you can take an action. Now, the reason why I am showing you this is for when I come to this slide. Okay. So before I go to that slide, just to show you some pictures of recipes and cookbooks. The terminology on Chef is very easy to understand. A junior person comes in, he becomes productive within 2 weeks. Okay. Recipes, they are a collection of resources. Cookbooks are basically a collection of recipes. The code, run lists are what you want, the list of things you want to run on every node. Okay. And everything is somewhat object oriented. Okay. So you have base classes and you can start building on top of those base classes. So the way to think about it is everybody would like to have monitoring systems in place on every node, right? So anybody creating any provisioning any server anywhere, you want that monitoring piece to be there. You want the security piece to be there. You don't want hardly kind of things to come in. So whatever basics you want, you put it in a base class. And that base is applied by default to any server you provision. So that just reduces a lot of work which is redundant, which you have to do for each server, which you have to do for each node. So that concept is basically shown over here. The Chef server has all the recipes and the node runs the recipes in a particular run list. So first install the NTP client, then install the OpenSSH server, then install Apache and then PHP. So and it runs it in this particular sequence, and each of these cookbooks are passed on to the node, and node does the basic heavy lifting. Since node is doing the major heavy lifting of exactly running this and compiling exactly what is required for it, the Chef server is very lightweight. That's why Chef scales to huge number of servers. So Facebook is using Chef, Amazon OpsWorks. Amazon OpsWorks by default uses Chef. It accepts all the Chef recipes. So it's significantly good in when it comes to scaling software, scaling across a huge amount of servers across continents. Any questions on this?
My one question is, it looks like a flat client, right? It's a flat client. What is the advantage on, so what are the disadvantages of using that?
Fat client, the disadvantage is it is going to take some memory and some CPU from your node, which if it's a critical business application, then people will that is the first question they ask.
Okay.
How much percentage CPU it will take? So generally we say 4% to 8%. And above 60% anyway we are going to create another copy of that server, because we will do the deployment in an elastic way.
Okay.
So we say that if it will not risk your critical business application by taking it to the limit that okay, if your business application itself is taking 85% of CPU and suddenly every 30 minutes the Chef client is going to run, and now 85 goes to 93, it is going to create a problem. So above 60% is a very good number which customers accept, saying that above 60% create a copy. So even if something runs once in a while, you want to go to 68, 70, but you'll come back to, you will never go, all your management systems, almost everybody, there are at least 4 to 5 agents running on, which are management agents running on these servers. and each of them take 4-5% CPU every once in a while. So, so that becomes a problem. So this is the disadvantage of it. And even agentless, it also runs SSH agent. Something has to run on the client to get the job done. But if server side is going to do a lot of heavy lifting, then the server has to be scalable.
Okay. How you work with Ansible on yours?
Sorry?
Your work on a stateless, right?
Yeah.
No agents.
There is an agent mode if you want, but by default it's not enabled. Like you don't use that. By default you are pushing things. What Chanak displayed, demo rather. So you have something running on your machine, or you can have an Ansible server and you push it to all the clients nodes. You don't have any software running on the node. Only dependency is that you have Python, which is available in all Linux distros by default. And yeah, I think there's one JSON module it uses, which is, I think, almost all the newer distros have it. So you don't need to do any specific setup on any machine to run Ansible. You can just start a new VM and run Ansible on it. That's the thing.
Ansible is more like only more capable towards Linux kind of stuff. I think so. Chef is more like
Yes, Chef is way more versatile. It's been around for a while. It has a lot more modules. There are a lot more things which are there. But yeah, Ansible is still much smaller project, right? And they are looking at supporting.
The rate of growth of Ansible is higher than Chef.
No, but Chef is much more head start.
It has been around for 5 years now.
Yes.
Because before I used to work, I mean, when those times we all IBM, we used to have Claycase, we used to have Tivoli, all these.
This big fix.
They were really huge. I would give like
They're
3-4 nights basket, you should just
Yeah.
configure. And you have to get it before Monday, man. That's the worst part.
So I was the global director of BMC Blade Logic.
Okay.
I visit all these customers, Metline, France Telecom, huge servers, thousands of SAP has 37,000 servers, managing patching for it and doing things like that. And the reason I started this thing of my own is because Chef I saw has huge potential, much simpler, much sleeker technology, and you don't need these blade logics and big fixes that are just like very bulky things and with very less support.
Yeah, I've just noticed like, just take that Claycase, they was Claycase, now we have GitHub, it's almost similar.
Yeah.
Same thing it is, but just more better, I would say.
Yeah.
Uh,
So these are unpredictable.
It's a pull based thing, right? So
Node will
at one time one node pulls, or suppose I want to configure say 35 servers, all the nodes will pull together or one by one?
It depends on when you started that Chef client. Each node, whenever that node starts, it will do its own pull. So it's a normal curve, I would say.
But then the server, it would be heavy for the server if all of them pull together.
Yeah, so that's right. It's a normal curve. Yeah. A normal curve basically 33% start. There are, but 66% of the nodes will ask data more or less around the same time.
Okay.
So, and Chef server can handle that much. It's running in Facebook,
Yeah.
and Facebook comes there every year in the Chef conf. Fidelity will also come and see the infrastructure it's managing and things like that. So, I'm
New England Center.
So scalability and connections, multiple connections, I don't think we have to worry. So I'm very confident on that one. So this is exactly how the code has to be written when you're defining roles. And all code I've seen only it's like this much. It's not like you have to get your head around huge thousands of lines of code. Nagios I've seen files that are slightly longer, but otherwise most of the files are very small. Okay. So here is the base role that I talked about. If you want some basic thing across all servers in your company, you can define it like this: name base. These are the recipes you want. Okay. This is a web server role which says add everything that is present in the base and then add engine serve. So this is how you keep on building things. Now tomorrow you want to change your SSH port from 22 to 2022. You add in the base. It will change in all the roles that is present everywhere because base is present everywhere else. So it gives you a very granular control over the configuration without sending images across the network, which is like the old technology of doing things. Okay. So these are the main concepts. Okay, you can have roles consist of other roles. Some roles consist of single recipe or multiple recipes. And knife is the command line workstation tool which controls the chef server and which adds chef client to your node. So this is the tool that you have to install in your workstation to do some coding on chef. So these are all kitchen related things. With knife you are creating recipes, cutting things, adding things to the server. So easy to understand.
That is if you're in the kitchen.
If you like cooking and master chef, so that's easy. Okay, so this is another example of a web server. What all do you want? You need NTP, OpenSSH, Apache, PHP. That's the role of a web server. Once that is defined, this is a database role definition. NTP, OpenSSH, SQL, and then you start assigning these roles to various nodes. Now search. This is the last topic we'll cover before we go to DevOps. The search is, before I show you search, I'll just show you one, this example which we had shown in the beginning. When the complexity of a deployment goes up and you have this kind of configuration that you are managing and you want to do dynamically, if JBoss application is facing a lot of load, you create a new JBoss app. Okay. Once this JBoss app is up, you have to again change the configuration. For each of the connecting modules, you want to connect JBoss app to your database, the memcache, and make these configurations in the appropriate conf files over here. Now this is not easy to remember that you have to do each of these things. Okay. So how Chef does it is over here. These lines of code is basically how it does it. So there are pool members. Pool is a list of web servers. JBoss web servers that I showed you. So from those pool of web servers, it is getting the unique pool members, and then it is restarting the HA proxy service. In the HA proxy service, it basically iterates through all the pool members. So now you, when you make this call every half an hour, and now it finds a new app server, so it will automatically use that app server's IP address. Because OHI runs on each of these machines, it collects those profiling information, it knows the IP address, FQDN, a lot of information about that server, and whatever is required, it puts that information in the load balancer part of it. So these two simple constructs give you elasticity, and it's cool when you really look at it running. It is beautiful, and we get a lot of money for doing this. So this was about the basics. There is another environment concept. Before I just show you the DevOps part of it. Now, how I use Chef in DevOps in the last 10 minutes. Okay, DevOps, basic ABCD of DevOps is developers say I want to add new features all the time, I want to change. Operations guy says everything is working, don't change anything, the stability part of it. And then this is the confusion. So from business to development, you have agile methodologies that fix it. From development to operations, that's DevOps. So DevOps is really catching on. Many customers are asking for DevOps related solutions. The goal of DevOps is to deliver high quality services on demand. Many people define it as how many times you can deploy your changes per day. Many people define DevOps as that. But it is not more about whether you can make 100 changes per day or not. It's more about can you roll out a change in your production environment when you want. Okay. So if you have large applications and you want to change once every week only, as long as you can do it on demand, you are doing a good job. Okay. So this is basic goal of DevOps, and how to achieve it is depicted through this diagram. So you can get your source code, you have to do unit testing, you have to do quality control, For quality control, you run some static code analysis tools. When you deploy it in various environments, you do testing using white box testing using JUnit, business-driven development testing using Cucumber. Then from pre-production to production, you can use some of these tools like Chef, Puppet to put into the production environment. So what Chef does is, you have seen the recipes. Chef recommends Git. Chef has concept of an environment. In every node, you can define a new attribute for yourself. You can say that this attribute is dev, this is pre-production. So now that machine becomes a part of that environment. So if you define that as pre-production, your nodes will come over here. Okay, now you can, through the search of the database, you can do one operation on all the machines in a pre-production environment. So it is as simple as that, just a simple query on the database table. Okay, so environment concept allows you to do these things. The automated deployment allows you to define an environment and create a lot of nodes on it, and you can configure the nodes as well. So once you run all your tests, you can destroy that environment once you have the test results, so that you can save a lot of costs for your company. So this is, and all this can be pulled together through Jenkins. Okay. So this is in a nutshell what we recommend customers for DevOps, on how much time it takes for your developer, once the code is ready, how much time it takes from that time to production. If you can speed this up, that means your application is becoming versionless. Okay, so this is the main concept that we sell. So which version of Facebook are you using? Which version of Gmail are you using? So these are means you are no longer keeping track of these versions, because you are just getting features every day. So if we can move our customers to that, then they are really on the cutting edge of this technology. And Chef addresses a lot of these points. You can create environments, you can create pre-production environment, you can deploy unit tests, you can start the run of unit tests, you can destroy environments. So it's quite powerful stuff. And then finally, the coordinations of various teams. We do the assessments of where each team is really slow, do the designing for it, on how can we really add automated tests on instrumentations, how to define an integration test, because there are a lot of combinations of how to create different environments with different Java versions, with different antiviruses. So Docker helps a lot in these areas as well. And then releasing things fast. So this is the last slide. In this last slide, in DevOps, we find out the maturity of a customer in these 5 columns. Okay. Data management, as you were saying earlier, it's quite tough because data has to be managed really in a special way. Binaries is one thing, configuration is one thing, dependencies is another thing. But data is really special. Okay. So when you are doing things across clouds, how to manage data is, you have to take a look at it in different ways. So when you are moving from level -1 to level 3, each of these changes, there is a separate slide deck which shows exactly what are the steps you need to take to get a particular team to optimizing stage. Okay. So it's not an overnight job. It's not at all an overnight job. It takes good amount of time and change in the mindsets of people as well. Okay. But in a nutshell, build management, continuous integration, environment and deployment, Chef really helps over here. Compliance management, Chef helps here as well. Deploying tests. So here, whatever tools you are using, you can slide Chef and add some artificial intelligence on top of it and do a good job at it. Data management, you have to look at it on a case-by-case basis. Okay. So any questions on the basics, fundamentals of Chef, the roles, the recipes, cookbooks, assigning it to a node, server-side pull mechanism, nodes pull those things, and then using the environments concepts and automated deployment concepts, using it in DevOps.
So I have one. In the Ansible, we have seen that there was a return mechanism. So if I install Nginx on a server, it will return me if that was successful or not, or whatever issues were there. Is there something like that?
Yeah, everything is ordered. Once one step is done, it will not start the second step. So everything is done in an ordered fashion.
It will notify me that it failed at this.
Yes. Yeah.
Okay. And what about running commands on the fly? Like I want to check if a service is running on all my web servers right now.
So right now is the main question. See, right now you don't get unless you pay for Chef. So there are two versions. One is free open source version. The enterprise version has this Chef metal concept, which I call the machine thing. And second is the running things right now. So that's also push. You want something, all the nodes to do something right now. So the diagram that I showed, that when you are adding a new app server, now you want the configuration to happen. That requires enterprise Chef. Otherwise you have to wait for 30 minutes for the next Chef client to automatically run. So so it's $5 per node per.
Simple running command, like I want to check the uptime of all the servers.
So basically, actually,
If you want
this
to-
is not what the configuration management system is designed to do, right? You want to, the idea about configuration management is to set up and correct whatever you like, to make the server set up for what you want to do, or to correct if there is an anomaly. This is what you're talking about, is the monitoring system.
Yeah, you're talking about
You configuration management system could handle it, but it would be very ugly, and it's not a correct tool to do the job.
Yeah, don't do that using Chef. Using Chef, you deploy Nagios or Icinga or Gania, one of these, and you collect the data and look at it in the dashboards. And if you want some automatic alerting, you can even put these tools like Elasticsearch, Kibana, and put alerts on top of it. It will give you alert immediately when something goes wrong. These are all free ones. You can do these things within like 1 or 2 days. And you can finish all these installations. So easy to do it through that mechanism. Okay. Any other questions? Okay, guys. Thank you very much for your time. As I said, there is chef training, which is my marketing pitch over here. If you want chef training, it's a paid training, but you get the chef certificate from US chef company. Okay. All right.
Thank you.
Thank you.
Okay, I contribute to certain Docker files and all those things. Okay, so we are going to talk about these things today. What are the challenges which are faced by a systems guy, a DevOps, a system administrator? What are the most natural solutions that we come up with? Why do we write scripts, but why they fail to scale? I'm gonna take a little bit look on how Puppet Chef tries to solve the problem, how Ansible is trying to solve the problem again, probably in a better way or not. That's for us to judge. Then I'm gonna talk a bit about how you can run ad hoc stuff. For example, somebody asked about ping thing. Who was the person who asked that? Can you run? Okay, it's not like okay. So somebody asked that, can I run ping commands on the fly, or can I see uptime on the fly? So how you can do that with Ansible. Then we're going to talk about scripted stuff, which is like for Puppet it's similar to modules, for Chef it's similar to cookbooks. So we have playbooks here. Why no agent and decentralization is a good idea, and of course what's wrong with Ansible, or what are the things which you are missing with Ansible, and how do you start using Ansible in general. Okay, so this is a standard system stuck in a wheel, because every day there are new servers coming in, there are new applications that are deployed, updates come in, so you have to keep up with all of these. You have to make sure that what all new services you have, what all new servers you have, all of them are identically same to each other. You don't want half of your infrastructure running some other version of Nginx and half of your infrastructure running some other version of Nginx. That's a very potential, problem and call of hazard. Our infrastructure these days tend to be very different. There are certain machines running in cloud, in EC2 or in rack space. We have some set of machines running in co-located data centers, and then we combine all of them and build a hybrid sort of thing. We tend to do a lot of initial configuration management, package installation, user creation, keys, a lot of things. New people come in and they leave. You have to manage the servers accordingly. You have to make sure that their keys are removed and new keys are put in. Access is revoked. Whatever credentials were being used during their tenure are revoked, and you generate new credentials. And then you have to communicate all those credentials to all other employees, right? So this all has to be taken care of. So your natural response is, okay, I can write a script for that, right? So that's the first thing that comes in your mind. Talking in some sense of pre-configuration management era, everything was, I can write a script for that. And then when configuration management came in place, you would try to write a Puppet module or a chef recipe or something like that. And then a natural next question will come to your mind would be that, would it scale, right? If I have 10 servers, it should work fine. If I have 100, it should work fine. For thousands, it should work fine. All these things. And next, would it be easy? Do you require some additional stuff for, scaling it to thousands of servers? And would you be able to sleep at night? So these are normal questions that come in your head. I think when Facebook tried to start with Chef, they did a lot of research and paid a huge chunk of money to Oxford to get the things done because Chef was still not there.
Even GE is doing that now.
Yeah.
For GE, Chef is changing some of the constructs to make it work for GE, and now that is almost coming to a final stage. So by the end of in the mid of August, I have to go and roll out that product in GE, Delhi. It's already rolled out in US and Europe, but they have to change the product.
Yeah, they have to make a lot of changes to scale on that level, and it's very difficult to say that configuration management which you are putting in place today will scale to your needs of tomorrow. So that's a very problematic situation. I don't know how Puppet did it. Puppet still manages around I guess more than 3 lakh nodes of CERN, which is twice the amount of Facebook. I don't know how they did it without any huge financial backing, but that's very impressive thing. Anyway, so talking about Ansible. Let's first talk why scripts fail to scale. How many of you have ever written Perl code? Anybody has written Perl code? Perl code?
Yeah, man.
Yeah. Do you agree to my first line?
Yeah.
Okay.
Any code which is more than 500 lines, I just.
You'll write again, right? You'll just rewrite.
I don't know, 500 plus lines.
Right. So what happens with scripts is that they tend to look dirty after a certain point of time. 6 months later, most probably you won't be able to read your own code. 1 year later, you will rewrite everything. There's a lot of code repetition. I mean, this thing has happened with me a lot of times. I start something with go to AWS, and I after writing 10 to 15 scripts, I realized that I'm again copy pasting authentication code everywhere. Instead, what should I done is that I should have made a module and just imported that. Right? That would have been much more Python-y way of doing things, right way of doing things, and it would have saved a lot of code for me. But I didn't do that. Okay. It's hard to remember the order of execution because so what happens in modular architecture is that you create a lot of modules, but you need to remember what module is supposed to run after which module, right? You cannot try to run PHP modules before installing HTTP modules. That will just backfire. So all of this you have to take care in case of scripts, that you run write script after the next write script. Okay, and of course documentation, our favorite task. So we usually don't like to document at all. Okay, Puppet or Chef. I don't have much experience with Chef. I have some experience with Puppet. Puppet or Chef, they need agent. So that's one thing which I think you said that once you reach 60%, you start spawning another server. a fair amount of CPU and memory is utilized by these servers, these agents, which can be a problem in certain scenarios if you are not doing the things in elastic way, or if you are, say, having maybe a static server or something. So that becomes a problem. You need to install dependencies. You need to install Ruby at least. For Puppet, I know you need to install other modules as well, like facts modules, which will generate all the data for facts, like which version, which OS, which user, which key, this, that, blah blah blah.
But things have changed both in Puppet and Ceph.
Maybe, yes, that's why the last line. Yes, sure. So you don't need those modules now?
Simple Puppet install Puppet master, Puppet does it, everything.
Yeah, it does it, but it installs that.
Obviously, you don't have to care about that, we're just installing, takes care of
No, but
it.
Ruby is needed on the server.
Ruby is
that's on the
You have a dependency before you can start with
Yeah.
it, right? Which is a different
Which needs configuration management, because you cannot run configuration management without configuring the server first,
Correct.
right? So
What
that's
he's
one.
saying is you don't have to do it. You said you have to do Ruby. He said that you don't have to do it. Puppet does it on.
I don't have any experience with Ruby. Maybe like a couple of years back I learned Ruby, but I haven't written a single line of code. But with Puppet and Ceph, I'm good to go. Means I can write anything without knowing Ruby. That's good.
Yeah, Puppet has its own DSL. You don't need to know Ruby. I think Chef still follows Ruby DSL.
Yes.
You need to know Ruby, right? Yeah. So that's. Well, own DSL has its own problem because now the portability reduces with Puppet. But I think Puppet has also introduced Ruby DSL.
It was.
I heard, I'm not sure.
Before 2.7, it's like 1.5 years back it was there, but now
So they removed it
they
again?
removed it altogether.
Awesome. Okay. Okay, so yeah, that happens a lot. The DSL can be problematic at times if you choose your own DSL. Okay. Now Ansible. Ansible uses YAML. YAML is a markup language. It's a very clean markup kind of thing, not like XML at all. It uses OpenSSH as transport, which I'm sure on this planet all the Linux have. Parallel ordered execution, which means that you can run Ansible parallelly on multitude of hosts, and the execution is ordered. Some things, it's a personal matter of taste. Puppet doesn't do ordered execution, right? So what happens is that if you are trying to run 3 classes, any of the class can execute whenever they feel like, unless you have a before required structure defined, which again is a pain. So with Ansible you don't need to do that. Everything is ordered, everything is executed in an ordered fashion. Agent is not required in servers. So that's one of the major things that all you need is a working Python 2.6 plus, and everything will work out of the box.
Just something. We have YML.
Yeah.
Does the values all variables have to go in YML? Is there anything which allows us to extend Ansible to say use JSON or XML?
Not that I know of.
Because the thing is, right now in my project, how I have is like we have 3 like I would say 3 kind of components. One is void site, where majorly it's free switch, where all the configuration files are all XML based. Then other end we have our own stack which is written completely in JavaScript, all Node.js stuff. And other is all the third, like we have basic sets like Nginx and Apache and anything else. So for those I am fine with using YAML. For using on the Node.js side, things are much better off and also the developers are much comfortable doing things in JSON. And there are just cross dependencies of variables that I want from free switch to which are used in Node.js. Like the free switch has somewhere it's defined which port does it use. So now I want my Node.js component to use that port and IP, right? So right now I have to kind of make templates and then create YML to actually make it into an XML file. which feels like a little
Yeah, I
stupid.
understand.
Because we are just converting it from one portable format to another.
Right.
So other thing which I'm looking at is probably having, if we already have modules, which kind of, since these are again the same kind of same thing, they're just different formats for putting in your variables.
Right.
So that's what I'm wondering if it already has or
I'm not aware of any such module. Though I don't think it should be very difficult to write one because JSON is also very easily readable.
Sure.
And so is YAML. So
yeah, just that I require that cross dependency to work correctly.
Yeah. No, I'm not. I don't think so. There's a readily tool available, but writing that should not be a very difficult task, I suppose.
I don't know, but why everyone is kind of right now moving to YAML. So I don't have that much experience with YAML, but in OpenStack we had first dependency with both XML and JSON. So now the new modules that we are coming up right now, projects that are Heat and I think all of them are using by default YAML.
Okay, and need to look up why is that happening. But yeah, just that
every one of us is comfortable with JSON and XML.
Yeah,
I guess
we have been using that.
No, I mean, what your question is?
So my question is that right now Ansible only supports like you put your variables and all in YML format. Now what's happening is I have free switch where the configuration files are completely defined in XML. So now what I have to do is I write a template to form a XML file. In that, put it as it's a Jinja template which Ansible supports. Then I make a YML dictionary to actually populate the XML file, which sounds kind of a hackish workaround because YML and XML are both supposed to be portable data formats. So I'm actually converting from one portable data format to another because Ansible supports only one of them. And it also makes the task little more difficult for my team because otherwise the thing is I need to kind of write a parser which will do this because the person who handles VoIP he's used to doing the free switch configuration in XML. The person who writes the Node.js code he's used to writing his configuration in JSON. Now they need to converge to doing YAML.
There's no JSON at all in the annual. Because going forward,
output is JSON.
Going on JSON just for
output is JSON.
Not at the moment.
Yeah, the input is not.
I don't think there is. They are even talking about moving to JSON.
YAML is actually having good readability.
Yeah, YAML was a thought out decision. It has better readability than Prettified. I mean, readability wise, YAML is very good. Even when you compare it to JSON, it's better. But I suppose parsability wise, since we are used to using JSON.
no, I just parsability just because it's so lightweight, na? All XML is always double. You should double tag.
YAML is same. YAML is not heavy.
No, XML compared to YAML is very heavy.
XML is heavy in itself.
And even JSON contains a lot of curly brackets and all, and it's not as readable as YAML.
That's what I'm saying. The readability with YAML is very good.
But then something that he is talking about should be available. I don't think.
Probably somebody needs to write those modules. So it's not that we need to write those modules.
Another GitHub project, please.
And I think at least JSON to YAML should not be very difficult. I'm not sure about XML.
It's very difficult. Yeah, it's very difficult. Literally, I was given this task and I just said no, I can't.
What? The JSON to YAML?
Yeah, just write all the configurations that you have there in JSON to YAML. I don't like that thing. I just give it to someone else.
Why isn't? What are the challenges?
Challenge is like, see, even if maybe like YAML is cool, but I personally I don't like it.
Even I did.
Yeah, that's the challenge. That's the challenge. That's the challenge. Maybe like by
Probably I think the best way would be to.
That's not a data limitation.
I think best way would for my problem would be probably to have the variables be allowed in XML and JSON. I'll have to speak to the people concerned with Ansible and say. In the end, what it does is it converts it into dictionaries and lists, right? It converts it into a Python format.
That's what I'm saying. Maybe JSON would be still doable, but XML I really doubt that anybody's gonna go down that road. Honestly.
just the personal choice. It's like using
yeah, I mean, both JSON and YAML evolved because of XML.
Right.
It forget that we don't want to use it. Okay, right. This is the scale at which I am using Ansible
What
right
is the
now.
other points? There were some other points.
What are the other points? Where did that slide go?
No, let's finish that.
Next. Open is the next.
No, finish that slide. We actually moved on to the next slide
Yeah.
when I asked the question.
So yeah, this is the scale at which I am using right now. I'm sure there are other companies who are using it, using Ansible at
Actually, we had Rackspace before that. They
Yeah,
use it internally, and they are, from what I know, they are the biggest.
quite possible.
Yeah, from what I've read up, that they are the biggest user of. They're the big Ansible, yeah.
I think the contributors come from there. That's the reason.
Quite possible. Yes.
Contributors come
Yeah,
from there.
yeah, internally also. So internally they don't have a policy on which configuration management tool to use. One of the webinars I attended said that they use all of them
Yeah.
internally, but the majority of the team is on Ansible. They have the they can choose what they want, but majority is on Ansible. They use it to spin up their servers and do some basic configuration and do their testing. Also, a lot of them prefer to do it in Ansible because of the syntax, the way it is that you don't need to write your tests, you don't need to, and it's like idempotent. Those things they found it much.
Everybody is idempotent. Everybody is idempotent.
Okay, I'm not too sure. Sorry.
Yeah.
See, they are convergent resources. Convergent resources are idempotent. So, ergo, they are also idempotent.
Yeah.
All right.
Okay. Right. So how do you get Ansible? You can get it from your package manager, yum or app, or you can use pip also provides the latest version. The thing about Ansible which you need to know is that if you can SSH to a server, you can run Ansible, right? You don't need to create a specific user account or something like that. As long as you, as a user, can log in and do it, Ansible can also log in and do it using your credentials.
I think only problem with it is with Arc. Arc Linux uses Python 3 by default.
ये आर्क लिनक्स में तो डिवाइड डायवर का प्रॉब्लम है क्या होते हैं बहुत सारा प्रॉब्लम डिवाइड
And so it has that, it requires 2.x, right?
Yes. For now.
So Python 2.x, so Ansible, sorry, Arc by default has Python 3. So that's one place where it's
I
like,
suppose they are the only ones.
yes, they are the only ones.
They are the only ones.
There are
That's
only
one-
ones that give a lot of problem आर्क डिवाइड डायवर्स उसमें बहुत सारी चीज नहीं मिलता फटता रहता है
Arc में.
Arc is.
बहुत सारा फटता है ये नहीं चलता है वो नहीं चलता है डिवाइड अरे डिवाइड लैपटॉप की स्क्रीन करी डिवाइड इज नॉट देयर
I haven't had that
Wi-Fi
issue.
will not work something.
Huh?
I haven't had that issue.
No, I had that. I put it on one of these laptops.
Depends on the driver if you have. They don't have enough
I
driver.
used it for maybe like 5 months or so to just to show off that I'm using Arc. But most of the times I've run into issues sometimes.
Probably since I use Slackware and all, Arc feels much easier. Slackware and Gen 2 coming from there, Arc is much easier.
Yeah, okay. I know that's like
You don't need to manage.
it only takes so much punishment.
You don't need to manage separate ACLs. For example, say one user as one DevOps user, he has permissions to create users, but he doesn't have permission to create user. And another one who is like super DevOps can do a lot more things. So these permissions are inherited with your credentials. You don't need to create separate ACLs. One thing which can be a problem with Puppet or Chef or whatever is that the agent run as root, SUID one, right? So what can happen potentially is that a bad manifest or a bad cookbook can destroy a lot because it has root privileges. With Ansible, that is very difficult to do because you are not running Ansible as root, you are running as your own user. If you can destroy, then only Ansible can destroy. So that ACL thing is built in because of SSH and PAM authentication modules. And another thing is that you can run ad hoc commands whenever you want along with the scripted commands. This is known as inventory file. Inventory file, the file which he just showed, Shaunak just showed some time ago. So this is like a bird's eye view. His was a bird's eye view, mine is like very simplified view. I have defined 2 web servers, 2 databases, and I have defined a SMTP server, and I am using the same server in this. So I did this on purpose to signify that a server can be a part of more than one groups, which is very true in real world when you can have one machine acting as maybe DB server, maybe Redis cache, or things like SMTP or HTTP or whatever. So all this happens there. So this is an example of how you run ad hoc stuff. So for example, if you want to see your web servers are alive or not, so what you can do is Ansible web server minus M stands for module. What module to run? Ping module. So I'm just going to run ping to all my web servers, and all the web servers which are alive will reply me with a POM. Okay. So you can run ad hoc commands. Now usually people say that there's not much utility of it, which I strongly deny. One very live practical example I had when Heartbleed was released, Heartbleed bug. During that time, I had to update all the servers, or I had to update all the OpenSSLs on all the servers. This was a lifesaver at that point of time. It's very difficult at that moment to maybe write a module and then wait for 30 minutes for your servers to get hold of all the configs and then
How do you get, see, suppose that patch or Heartbeat was, Heartbeat, if I send it out by Ansible, how do I get confirmation, that is done?
you will get confirmation, like this guy replied in POM, right? You will get a confirmation that installed.
But this is how this, suppose how double entry accounting works, right? One guy does it and then another check and balances. So is there somewhere like that we're not okay? This what Ansible did it and I'm getting a positive, but there's somewhere else that goes and confirms was update why.
Okay, I'm actually not getting the concept.
Actually, there's an alternative tool called mcollective. वो update करता है and you actually see what it is doing on the screen itself.
How Ansible does that?
Ansible does that.
Ansible does that. mcollective is usually used in conjunction.
mcollective will run a single command across whichever command you specify across multiple servers.
Right.
So I guess even Ansible is doing it in a similar fashion.
Probably.
As soon as you run the command across multiple servers, you will see your screen getting updated or whatever logs.
Only thing with mcollective is that you need to run mcollective servers on all the machines.
Yeah. The same thing happens with
There is a mcollective server.
Really?
Yeah. And then you have to set up a message queue as well.
No, we don't have that kind of setup. Not really sure, but I haven't seen.
I remember in Directa at least a couple of years ago, Mohit was working on that.
Mohit Chawla?
Yeah.
Okay.
And he had set up a message queue, I think AMQP or something like that, and RabbitMQ I suppose he was using. The entire setup was there would be mcollective servers on all the machines and messaging queue. And when he wants to run something, he would use mcollective client, fire the command. It will go via message queue to all the mcollective servers, and then mcollective servers will run that. So this was a Puppet mcollective combo which he built, which becomes a very redundant thing via this, because now you have a Puppet agent running on your servers, as well as you have a mcollective server running on your machines, which creates, you are adding more and more components. So that's something which I personally don't like. Okay, right. Yet another example. So you were asking about how ad hoc commands happen. So I just did a echo hello and I get a reply. This command executed across all the servers using command module, and I got a reply of what was spit out on the shell. So similarly, if I do a yum update OpenSSL or OpenSSL devil, I will get the entire repository metadata, what all got updated, what all got downloaded, and everything. So the app is actually real time. I can run this parallelly on a lot of servers. I don't have to do it one by one. And so this actually speeds up the process a lot. So one thing, I get a return code which signifies that command was actually successful. Okay, and this is a scripted playbook. So playbooks are similar to what you have. You have a recipe or you have a manifest modules in Puppet. So similar to that, it's a very simple playbook. It just install database. What it does is, I have named it Awesome Service, and it will run this playbook on all the servers that were listed in database group. So we define grouping in inventory file sometime. So it will go there, check out all the servers, and then it's gonna copy the config and put it here in the destination. It will notify the MySQL service. So it will notify that you need to restart something. And restart MySQL service actually runs this. Right? So you can module all the commands. I've shown it in a single file, but as best practices go, you should actually split them in roles and playbooks and handlers. So those are best practices which should be followed. Right. Now let's talk about decentralization. So what happens with any other configuration tool is that your users cannot run it on fly, right? You have to first put it in your repository. Your agent will take a pull and it will execute. Here with Ansible, although that is supported, but that's not the conventional way to use it. What we do is anybody who has right kind of authorization can go and run Ansible playbooks. So this can be lifesaver a lot of times. Since there is no centralization, there is no scope of my Puppet master bombed out or my chef server, what do you call it, that bombed out or something like that. So that's one less server to manage and one less bit of pain which you have to go through. It works from everywhere. As long as you can SSH into the server, the thing will just work. Okay.
The Ansible server is not the same as Chef server?
There is no Ansible server.
There is no server.
So then from where are you running this?
Maybe my laptop, wherever. If as long as I have my SSH keys, I can run it from any machine whatsoever. All I need to do is have the Ansible playbooks with me on my machine and ability to SSH to the remote server. If I can do that, I can do.
Okay, so there is no database. So you can download your playbooks wherever you have.
Right.
So there is no database component. So that's why you can just take it down anywhere.
Right. I can run it from anywhere. There is no database component. There is actually no. That's why it's like true decentralization. Anybody can run it from anywhere, and there's no need of a central node. There's no need of one thing which although it's good, but I didn't like in Puppet was the initial key signing that happens. Just to authenticate that it's the right one. Something equivalent would be there in Chef as well.
So they have now introduced the decentralization both in, I'm not sure of Chef right now, but in Puppet it is there. Maybe like I will demonstrate it next. Why it's like having a master slave configuration, sometimes you don't want to have all of your configurations in each and every node first thing.
Right.
That's the good thing, and the down thing is that what if your master server goes down? That's one thing. So Puppet does support the same thing, like you can have all your
I know
configurations.
Puppet had a standalone mode sometimes.
Yeah,
you have
masterless.
both the Chef also.
Standalone mode is.
Masterless is there. Chef solo is also there.
We have got
Yeah, Chef Solo, yes.
the one that I'm using right now. We have got a Git repo. Every agent basically pulls down from the tag Git repo.
Right.
And it works. So like you don't have to go for certification and all those issues.
Right. So yeah, that's one way to work around.
Yeah.
It's very similar to what it's doing. It's just that here you don't need an agent, and there you can run it standalone. Right? Standalone works. Actually, standalone works pretty good because there are certain times when your manifest is too big, and most of the times network will create a huge bottleneck for you. This happened a lot if there's someone who's from direct type. Right. Nagio server, we were never ever able to run via network. Puppet on that. So we moved on to standalone. I don't know if the same situation is there because it used to parse CSVs to generate the configs.
So we people moved from CSV to YAML for performance reasons.
Right.
So that was one reason why we preferred YAML. Then decentralization of Nagios has happened because of that.
Yeah, so I think that happened before. I mean after my time. So when I was there, it was very very, it was a nightmarish experience to run Puppet. So we actually pulled it out of Puppet Master and we used to run Puppet standalone, and each run would take 30 minutes. So even if you have to change a semicolon or just a host name change, it will take 30 minutes to propagate to Nagios. And something like Nagios sitting idle is like, Nagios is usually very critical, and I don't want 30 minutes worth pain in my next slide. Okay, right, we've discussed this. Okay, pitfalls at Ansible. What's not that good with Ansible? Ansible Galaxy was launched actually recently. So it's very new. It has less support as compared to Chef or Puppet. Less backers comparatively. This is usually a very big pain, that war stories are very less. So what Puppet and Chef have matured over the time. If you are facing a problem, chances are that somebody else has faced the problem already, and most probably you'll find the solution online. But with Ansible, that's very less. Although it's improving day by day as we are going on. Windows is not supported, so that's another thing. People who manage Windows, that's a problem for them.
They've actually added Windows support very recently, but right now it's beta.
Yeah, it's beta.
With PowerShell and
very
having
recently,
issues.
PowerShell and all. But I don't know if it will work across all the Windows flavors also.
Yeah, it's still right now very.
Even for Chef and this thing, it is just less than 2 years old. Windows support.
Yeah.
But now they have 3-4 months back they added support for Azure.
Okay.
So they added for marketing thing. Okay. So here Windows is not, it's still in beta.
Right. Ansible, the support for Windows is not that mature yet as compared to.
They just introduced it.
They
Like,
just-
not even like, yeah, I wouldn't even say problem, not even beta.
So it's very new there. This is my personal crib, last one. That just nothing works on VMware ESXi. Be it Puppet, Chef, Ansible, nothing works on that.
Is ESXi different than vCloud?
vCloud I think uses similar things in backend. So this is hypervisor. vCloud I think is a way you connect to hypervisor, right? That's my understanding, but I'm not sure.
Yeah, vCloud Director is a
It's a way
one more
to
layer
connect.
on top of several ESXi's where you just do basic resource management.
Right.
Chef was.
Chef works.
On ESXi?
Yeah.
No, how can it work? There's no Ruby.
Oh, not on that. Okay, on the VMs. Correct.
It cannot work there.
Why? What was the reason?
There's no Ruby. Even the Python is so stripped down that there's no platform module. You cannot
Chef has
do
got
input.
this provisioning modules right now written. So
That would use vCloud, right? vCloud API.
Yeah.
I'm talking about direct access. vCloud API is a paid and very expensive thing as far as I know, right?
vCloud.
Yeah, yes. vCloud Director is a big Linux module.
It's a very heavy paid and the pricing module, if you can understand it, it's like you have achieved half of like chartered accountant status. It depends on number of cores you have and what kind of CPU you have, memory, CPU cycles, and then a weird mixture of all those things and what kind of things you.
But then if vCloud works, won't the same plugin work for this as well?
So what happens is that Chef or Puppet or whatever, it will interact with vCloud, and then vCloud in turn will interact with ESXi. You cannot directly interact with ESXi. Directly interacting with ESXi is very difficult.
When you say Windows or Mac OS is what? On the target machine or?
Yes, that
Target. Okay.
As a server, it does not work even today. Chef server does not work on Windows.
Yeah.
It can manage a Windows machine. Server doesn't.
No, I was just thinking because see, I was looking for my enterprise. Enterprise will have Windows, because user will have a Windows ही रहेगा. Suppose उनको Word or PPT से ज़्यादा कुछ नहीं. So if I can't touch that target, and mostly if you look at an enterprise, very few are Linux, and mostly all these 20,000 are all PCs.
That's the
Mac is very nicely manageable.
No, but when PCs, if you look at any organization now today, I mean, just say, don't take a technical like direct, take anything else, like some other companies, You want to
He's
push
right
the updates.
actually. If you look at HCL or any other those kind of companies now, everything is Windows. If you look at Google, DirectI, ClearTrade, whatever, then you find Mac and Linux and Windows. Windows maybe, I don't know.
Yeah, because we have all Macs and
Yeah.
Because there are browser stack. I'm just looking at your
Yeah,
side,
right,
but
right.
look at like Tata is a company. You go something like
Right.
that. Lipton ऐसे कुछ तो उसका तो ऐसे ही मिलेगा. You get a lot of people working on Windows and very few working on actually Macs and all this.
Right. Yep, that's true. I think for that you might have to look into AD or something of that sort. That might be.
He's from the IT directory. Nobody gonna give access. Boss.
Okay. Last one. How do you start with Ansible? Just install the Ansible and try to set up your laptop. It's very easy. The YAML format is very easy to understand. You just start with ad hoc commands first, like simple commands like ls or something like that. That will help you to understand how things are going behind the scenes for Ansible. Check out the Getting Started guide in Ansible docs. It's a very nice guide. Step by step, they have done everything like how to set up a machine, how to run commands, how to write small playbooks, and all those things.
Hey, one question on the commands.
Yep.
So are those heterogeneous commands? Let's say it's a service start. It will run on any platform, anywhere. Does it convert those commands to the appropriate platform?
No, if you are using command module, then it will run your command as is. It will not translate. But if you are running if you are using distribution specific modules, there are specific modules for distribution as well, like package module. Then it will install. It will look into I need to use apt-get or I need to use.
No, but I think what he's talking about is service module. That service handles all.
If there is a service, if you are so you talk about ad hoc commands, right? So that's what I'm trying to do. If you are running something like a command module, then your command module will take your command and run it there. If you are using services module or package module or something, or some module which does a specific task, then there are translations. So it depends on what kind of module you are actually using.
So like I'll say two different things. Like package manager, you have different package modules for different package managers. Like if you don't have a single module which says install my package in any distribution. So instead you have like app module, you have RPM module, and but for services you have like you do a service Nginx restart, and whatever format it is, like if you're using init or whatever, it will manage, look at that and do that. That much it does.
So it depends on what kind of module and how you do it.
So yeah, how that module has been written to
Yeah.
handle things.
So I think that's one more thing which goes into pitfalls, that Ansible is not there yet that can translate all the things fully. The maturity level is coming, but still not there. That's it. If you have questions or anything.
We had our chance to
Usually I never
It's
can.
very
Smaller crowd than
I can remove this.
Thanks, sir.
Thanks, Harish.
On Capistrano. So out there are a lot of frameworks like Puppet, Chef, Fabric, etc., etc. So why another framework? Why Capistrano? So a lot of people talk about infrastructure as a service, automating infrastructure, code management, configuration management, and all that thing. Okay? What if you don't even have an infrastructure? One or two servers are there. That's it. There's nothing more. Okay. In such a case, you won't be, the overhead of setting up Puppet or Chef or Ansible would be a lot more than, focusing on the main thing. If you are just starting, if you are if you just started writing codes like 1 or 2 days back, you can use Capistrano. This will be a huge time saver for a lot of things. First of all, it will help you focus on what actually matters. So when you start writing an app, your main focus is on the logic, okay, not the server related codes and tasks. So Capistrano will help you reduce, save that time, that amount of time. So after this overview, I'll give you a demo where you can see, how easy it is to set up, how quick tasks run. Okay. Then increase the deployment frequency. So now when you are, writing an app, you are focused on deploying features. So this will help you increase the deployment frequency. If you fail, then you can roll back pretty quickly, and it's really quick. You can roll back within less than a minute. Then role-based server management, everybody is familiar with that, I know. Then low learning curve. Then this is typically suited for small and medium-sized projects. So what I'll tell you, if you have around like 5 to 10 servers, you can use it. But if your infrastructure grows more than that, go for Puppet Chef or any other enterprise level automation tool.
So what is the break-even point is in? After 10 servers?
After 10 servers, just simply switch over to other tools.
It's a wrapper on NetSSL tool, right?
Yeah. So basically, to run Capistrano, you require Ruby on the machine from you will be executing the commands, and the remote servers on which those commands and whatever it will be executed requires SSH to access. So the learning curve, a noob who basically knows nothing, who doesn't have a Ruby or Linux skill, will take a lot of time compared to a Rubyist or a sysadmin or a person who knows Ruby plus Linux on me. Because no, seriously, this tool took me around 2 days to understand and start writing deploying my own shit.
20, 30, 40.
The kind of ninja like me. Metadata, additional info, documentation over there. These people have a website where these people have, listed out a lot of examples which you can use to deploy. Just copy paste and start deploying it. Community support is decent, not as good as Puppet or Chef, but it's quite decent, and you'll get to see a lot of blog posts regarding how to set up Capistrano. And once you set up Capistrano, you'll automatically come to know what you have to do next. So that's the good thing. Then there are alternative tools like Puppet, Fabric, etc. Disadvantages. So disadvantages come because of Ruby. This tool depends upon Ruby. Now different versions of Ruby can very quickly become an issue. For example, let us say that 2 users are using the same Capistrano code, but one user is using Ruby 1.9 and other one is using Ruby 2.1. So there might be, the code might be same, but due to differences in Ruby, there could be incompatibilities. So the steep learning curve for beginners. This is not a tool that you can, just decide one day and start learning it. If you know Ruby, if you know Linux, then this tool is very easy to pick up. Scaling at an enterprise level using Capistrano is a huge overhead. Because then you'll have to write modules by yourself, which are already available in Puppet or Chef. Then works out of the box for Rails, because this tool was built as an automation tool with Rails in mind. So things like PHP and Python might need some of the modules to be rewritten. But I have actually, Capistrano can be used for any other thing like EC2 deployment or PHP based application. It's not specific to Rails or anything. Yeah. So regarding the demo setup, I'll give you a quick overview of what I'll be showing you. My laptop, which is from which I'll be executing commands on the remote server. I have a VPS where only my SSH user is present, and I have added public keys to that particular user. So when I fire commands from my laptop, it will be, that user will SSH into the box and execute commands over there. And as and when the commands are getting executed, on the terminal you will see what exactly is happening. So the laptop from which, the system from which you execute the commands require these things, Ruby and Capistrano. But the remote server that doesn't, remote server doesn't require any kind of installation as such. You just need the user and his public keys to be present on the remote box. And what exactly happens when you, start deploying? So, say for example, you have an application and you have a Git repository or GitHub repository, whatever. So, when you decide to deploy it on a VPS box, Capistrano, first of it creates this thing, a symlink called current folder, and the current folder will be pointing out to the this thing, release number. So when I give a demo, it will become much more clear. I mean, it will become more clear as why Capistrano does this. So I'll start with the demo.
Is there a way to do rolling deploys?
Rolling deploys as in maintaining
I
releases.
deploy on like 3 out of, like I have, say it's I deploy on 2 and let's 6.
Role-based deploy.
Not exactly role-based deploy. So A/B testing sort of deploy.
Not really. I didn't get you. Can you give me an example? Like you have 3 servers.
I have 3 servers. I
Okay.
want one to behave in a different way.
What to behave?
Or maybe I want to deploy on one, do some operation on that one, and then put it back in production.
I
Yeah.
think it might be better off. I don't think Capistrano does that.
I
You
don't
direct with a
it will do that. So what you can do is you can attach a tag. I mean, you use roles you can achieve that using roles. So say for something you can attach a role like my initial testing server or something like that.
No, okay, not of that. Okay, I'll give you a very actual example. So we are in EC2, we have a load balancer. Behind load balancer there are 6 different machines.
6 different machines.
What I want to do is take a machine out of load balancer, deploy on it and put it back. Take another machine out, deploy on it, put it back.
Oh.
The reason I am doing that is because at the time of deploying the machine is in inconsistent state. Right? I don't want this particular machine to serve traffic while the deploy is going on.
That can be done.
How?
Actually, so that was the topic I wasn't going to cover over here because it becomes slightly advanced. But
We
there
are
are.
advanced people today.
I made this presentation from point of view of developer users, not from sysadmins or DevOps. So there are things like before actions. Before executing a particular action, you can configure a before block and use that before block to run
That
whatever you want to
has
do.
a problem that before block is executed on all of them. I don't want all of my machines out of load balancer because
Okay.
that makes my website down.
So I am not really sure if Capistrano is capable of that. So I'll have to look deeper into the options, but not really sure if that is possible.
How easy would it be to tie Capistrano to your config management system to do this?
Who's asking?
Just generally.
Capistrano to config management. I didn't get your question.
Yeah, I don't understand the use case.
What do you mean?
It will do this, like you say, like Ansible has these properties that you're talking about, being able to take it out of the load balancer.
Provisioning machine.
I'm not saying Ansible has this property at
No,
all.
it has. You can take it out of your single machine out of the
You
load balancer.
can. but-
Yeah, it has all the modules to do that, right?
Yeah, but that somebody has written EC2 module and using that EC2 module it can do that. But I'm sure that EC2 module won't be portable to any other cloud.
Right.
So it's not a very generic thing which can be easily achieved.
Okay.
Going by that philosophy, if I have to write a module, I can do that for Capistrano as well. I can wrap it around a Ruby script which will take out a machine and
which is a
grab
custom
load.
solution and can be done
Right,
with
so
this.
that's possible. But I'm wondering if there is a generic solution which will work across everything.
Okay.
So I'll start with the demo.
रिमेक कहाँ गया
हाँ, उसने बोला 4 बजे निकलना है।
यार उसका सेशन बाकी
Can Ansible be tested? Is there a testing tool for it? Like we have kitchen CI for that.
So I had actually searched for this, and there's a couple of threads around. So the way they think is that you shouldn't really be required to test.
That's the answer everyone gives.
Yeah. So they say only thing you would want to do is unit test the internal modules, but not your scripts. That's the philosophy they follow. That's what they
If
say.
there are a large number of servers, you would really
So they say that a lot of people what they prefer is they have their virtualized environment where they simulate things, then they deploy it to their real environment. That's they have to
How are you doing, chef? Knives here, what he said?
Kitchen sink.
There is a
Something on his test.
similar to no-op mode. That is there.
Sorry, what?
So there is a test mode.
Yes,
or
but
whatever you call it.
that's very
Yeah,
very.
it's not exactly what he's looking for,
Yes.
but it will dry run your
Hmm.
modules for you, your playbooks for you
Dry run where?
on the remote. It won't actually execute the command. It will just show
They
you
will
the,
show you what can be changed. It won't even show you the changes. It will show you what is potentially changing.
yeah. Obviously, it cannot exactly do that.
Yeah.
But it gives you a good enough idea. It's not exactly a test.
No, I didn't understand what does it test. I mean, when you say it does run dry run, exactly like.
We are completely moved away from Capistrano.
Yeah. So I'm in my repository and these are files that belong to my app. So there's a command line tool which Capistrano uses called cap. So using cap, first of all, let us set up some configuration files from which we'll be editing. So this is how you can create environments, production environment, development, beta. So I'm creating those 4 environments right now. Yeah. So what Capistrano will do is it will use the config file and then create all those files inside them. So okay, fine. So now my config files are present. I'll be setting up SSH now. This is actually a one-time thing, but I am starting from scratch over here. See, over here you can set up roles.
You must be reading less, you know. Even you have the bigger pattern.
Username on that file.
No, right now I'm simply
Yeah.
setting.
When you change the SSH key, the username was the part to the SSH key.
The path to the SSH. I don't think that's an issue. What are you?
No, their path home.
Okay. Thanks for pointing that out. So I'll tell you what all options I have specified over there.
You come with this put extra. See, the first few lines are taken up by the top. You
Some
can't see.
extra lines. Huh?
बोल यार मेरा बच्चा कहाँ है अभी भी है
वही है अभी तक पड़ा हुआ है बाप रे
वो अपने इंडिया का प्रोजेक्ट था वो हैकेथॉन मेरा बच्चा कहाँ है
Finally, this is all set up. So I did a few things like specifying the server name, specifying the SSH keys, and the path on the remote server where my files are supposed to be deployed, my application files where they are supposed to be deployed. So I'll simply say gap.
And then,
Okay, thanks. Which was the file? Okay. So gap, specifying the environment. I'm saying deploy.
maybe you can explain what's going on while it's doing that.
Okay, so what this will do is it will log into the this remote server and it will fetch the repository over there. In the specified this thing deployment path that I specified. Then once that is done, it will create some directories and symlinks. So once that is done, we can log into the box and I'll show you how it is set up. So what will happen is, once you look at that, you will understand, how it is managing all those things, managing multiple releases and all.
So the deployment, is it threaded or is it like one server at a time kind of?
So at a time.
Or one folder at a time? Like,
You mean serially? And
yeah, is it doing this serially or is it going like parallel?
Example.com.
Oh, something weird has happened. Got it. Okay, fine. Okay, so right now running into some kind of troubles. I won't be spending time into debugging, but I have ran it locally in my machine. So I'll show you what happens after the deployment procedure is completed. This kind of folder structure you will get after deploying the app. So what will happen is, this releases is the folder where whenever you make a change and push, so releases will contain the different code, code releases. So currently I pushed only 2 changes, so that's the reason why it is showing me 2. And the current symlink is pointing to the latest one, this one. So, in your web server like nginx.conf, you simply have to specify the path of this current directory as your document root, and then nginx will, the rest of the things will be managed by Capistrano. You won't have to change your nginx conf at all. So, using the command cap and specifying the environment and then deploy, this it will create this kind of a directory structure. Now, for example, I won't be able to show you the rollback step, but say for example, if you pushed a change and it failed on the remote server, so you want to roll back pretty quickly, you just have to use this command. Yep, that's it. So as soon as you hit this command, it will log into the server and go back to the previous revision, and then gzip the whichever failed release that release that failed, and then it will go back to the previous revision. So as you can see, this was the revision that I rolled, and this was the previous revision. Now it is pointing to the previous revision actually. So yeah. So if you look at the config file, so there are certain options over here. Like first of all, you'll have to specify the repo URL in the config file. Then you can specify the branch. So say for example, every user has a particular branch on which they test out their changes. You can specify the particular branch over there. Then use that particular environment and execute it over there. So branch. Then you can specify the deploy path, where exactly the path should land. Where exactly the files should land. Then there are things like log level. If you are using particular JRuby or something very specific, then you can specify the Ruby path as well. But if your application doesn't depend on Ruby, then you won't even have to touch all those options. Yeah, and regarding custom tasks. So say for example, Capistrano has certain inbuilt tasks. So these are basically, these tasks are similar to rake tasks. So, the code for those tasks are written in Ruby. These are some of the tasks that you will get by default. So, like I use the, use the first task to deploy a new release. So there are other tasks which you can use to roll back or revert any service or anything. So you can even write a custom task, and the task is not specifically restricted to this thing Ruby specific code or something, but you can actually write a proper bash command in it and then execute it on the remote servers. So that kind of flexibility is there, and this will save you a lot of time, because then you won't have to log into the server and execute all those commands manually or anything. Just start hitting commands from your terminal and you're done. Rollback or release a new thing or test, whatever, install application. That's it.
Okay.
Any questions?
What will you use Capistrano? What will you use Capistrano?
So I have a website. So whenever I feel like taking a backup of something, I don't want to log into the server, wait for SSH to happen, and then take this thing manually. I have automated it. I just hit one command. It will take the backup of my Postgres database and save it on Dropbox. If I want to revert it back, I have configured for that as well. So I just hit one line of command from my laptop and everything happens in the background. I don't have to worry about it getting getting involved in all those things. So if you are just one or two people, trying to develop an application, and you don't want to, you just want to cut down the time you spend on server related tasks. So this is a pretty good tool.
Thank you.
Wrap it up as soon as possible. My plan was to go for 1 hour, and I had it. Obviously not 1 hour. Actually, I'm also kind of late. So let's try it in 15 minutes. Okay. So how many of you guys have used Puppet? Most of us.
Don't ask me a question. It's a question of efficiency in DevOps.
You can assume that everyone is.
Okay, cool. Getting started with Puppets, yeah. So I'm not in. My plan was to not to go in much advanced stuff like classes and all. Just kind of starting, just to have a look what Puppet does, the way that you have seen Ansible, Capistrano, and other things that would happen. Not sure. Okay. What happened? Oh.
Kai.
Yeah. Me, I'm Ashish, OpenStack developer, cloud engineering, Reliance Jio. This is it.
Ignore that.
Yeah.
Arey yaar, I'll disable it.
What is that?
Center problem.
Fine. Let's see what's doing.
So this is a good hack, man. Huh?
Which one?
HDMI cable नहीं है तो हैंग आउट नहीं.
But it even took his, when his laptop got locked, it took that as well?
What?
You just entered your key, right?
Yeah.
Which laptop did it got locked? Yours.
Mine.
Then how did Hangout capture that as well?
Why? It's already authenticated. It's maintaining the session.
Okay, so it will show all the.
Yeah.
Till it is smart people, yes. Smart choices.
Okay.
Sir.
What is perfect? Everyone knows that. Definition of IT automation software that defines blah 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 and all these things.
I love this session.
No, believe me. It's like in one of the colleges I go and for such kind of things. So you have to go through each and everything. So sorry for that. Okay, so written in declarative languages, meaning you tell Puppet what results you want and you don't care how to get there. So what it does basically, it defines the desired state of infrastructure, standard configuration changes before enforcing them. This is the most important thing. It's not going to simply go and enforce it, it will first simulate it. So if something goes wrong, you're going to see beforehand before it gets enforced. It does it automatically and it reports the difference between the changes that it's going to make. And how it's doing all of it, I've just copied this diagram from Puppet Labs documentation. It's very important. So it's a 4-step process. So first one is that we have got a Puppet master and node. Can kind of forget about these things. Like you can have a single Puppet master or like a single Puppet node that's gonna do the whole job. But yes, we're gonna have a look at this. So first of all, a node, we got to call it as an agent, sends its facts. Okay, facts as in means whatever the data it is having that we have configured it, or that what we want to, what state of system we want to have to the Puppet master. Puppet master looks into its catalog. Basically, you can say looks into its manifest. What are the definitions? If it matches, okay. If it's not matches, maybe like you have made certain changes. It reports back to the node. Okay, node does the whatever things Puppet master asks it to does. That we call it as a report. And finally, Puppet master prepares a report of it. The 4th part, I don't care about that. So it's like if you want to have a report collector, just send it to some third-party tool, whichever you want. So this is the 3-step process. First one is that node submits the facts. The factor is there. Second one, Puppet master looks in the catalog, see if there is changes. If there is no change, okay, fine. If there is some changes, ask the node to apply those changes. And finally, once the changes have been configured, the node sends the report back to Puppet master. Everything is okay then. Okay, straight away to setup. Okay, so I'm not going to go for this setup. Just I will walk through it. But yes, it's very lovely because you can I don't know about Ansible and Capistrano. You have to go through all those stuff. But Puppet, maybe like it has developed in this course of 9 years now, so it's pretty simple to do things. So maybe like you can learn it in half an hour or so. Okay?
Dude, seriously, half an hour.
Come on, I'm not joking. If you want, I can just teach you now.
Now we can't debate, we don't have half an hour.
Okay, so fine. What are things that we require is fine. I said like 1 Puppet node or 2, 3 slave nodes, as many as you want. Or if you want to just try it on a single node, that's fine, no issues. We're going to see first on if you want to do on a single node, and the next part will be the master slave configuration. Okay, obviously if you guys would like to, someone wants to learn, actually I had, what do you call it, if you can see there, I had some VMs already open, but I'm not doing that. Okay, so yeah, for that changes that you required is like what I did in a master node. This is pretty simple sysadmin stuff, everyone does that thing. So this is my master node, so what I have set a FQD in there. And these are my 3 slave nodes. Okay, simple. Why? Just want to You don't have to SSH. We don't use SSH. Huh? We don't use SSH in Puppet. It's a certification style. And similarly, in slave node, what you do just you have to put in the where your master is. Okay. And in FQDN, if you don't have FQDN, no issues. Puppet does it automatically for you. But I did it myself. That's fine. Okay. Installation Puppet Master. I use Ubuntu. Update install Puppet Master. Fedora, whatever you install Puppet Master, Zyper, work now fine. Okay. So once we are done with Puppet Master installation, okay. So what next? We are good to go with Puppet. That's it. So for example, I'm not going to touch what the VMs. So it's not see like for example, if what will happen if I run Puppet resource user list, is gonna give the complete. We are defining Puppet after that resource and after that what type of resource we want. Like for example, I want the resource as user. Okay, so it's gonna pop out the whole of the resources that we are going to have. So give me a second. I'll maybe like I'll run here. Okay, so you can see why I just did it. Can you guys see this thing properly? Okay, so it has just given me all of the resources that is available on my system. Specifically, I have talked about the user resources. So with certain things like insert, present, comment, group ID, home, password, what all things. Okay, and see right now I'm running everything on a single node. So it's like you can run Puppet on single node as well, or Puppet master slave configuration, whichever you want. And if you want to just look into the what you call it, a specific user, like I want to check about a specific user like me, Ashish, I can simply say. So it's gonna pull you out the information about the Ashish user. Okay, you can change, you can define it on runtime as well. Like for example, create a new user with certain like cell, password, whatever. You can do that thing. It's gonna create it. You can check it as well. It's going to do that. Just I ran these commands on terminal and I copied and pasted the output here. Okay, similarly removing a user and all these things. So just okay. So why actually just showing you these things like as you are managing multiple nodes, you can manage the single node. So we can have thousands of nodes in this configuration only where we are running only Puppet Master. When you are running Puppet Master, it runs Puppet agent as well as Puppet Master. So what if we are going to run the master slave configuration? So we already have a master where we have installed Puppet Master, and all of the agent nodes, the one thing that you have to do is you have to install the Puppet. That's it. What it's gonna do, and if you want to run it, so things have changed. I checked it yesterday only in the latest release that was released in July some day. I don't know. It's the first week itself. Earlier, what would happen that when you are installing Puppet, Puppet agent will not be running. So you have to install, you have to run it yourself. So now when you are running it, when you're installing it, by default it starts Puppet. Okay, so right now it's creating issues for me. I don't know how to deal with that. So simple is that when I'm running Puppet isn't there, so I just say not create a daemon for that. Okay, just run it as a one-time user. So what it does basically, we are configuring Puppet Master and we are providing the server, Puppet Master server. Okay, so what the good thing is that you can have several Puppet Master server, okay, and you can specify server while you are running the Puppet agent. So what it will do, it will look into this Puppet Master server and whatever the configurations are there, we call it as like the manifest, will run it here. Fine, I'm not going to run it right now. Okay, so for when we are running it for the first time, so what it does, first of all, it sends us for a certificate. Okay, so it will send a certificate that you can see on a Puppet Master. When you say Puppet cert list, you're gonna find that there is a cert request from Puppet node 1 something, and the next thing you have to do is what? You have to sign it. So if you want, you can accept it. If you want, you can reject it depending on what configuration. So it's like any node which is having a Puppet node installed. Simple. Puppet install can send this request to any of the Puppet Master node. So it depends. Like if your node is in your network or if it is an outside network, just only it has to know the IP of the Puppet Master. So it can send the request. So now the puppet master has to basically decide if he wants to sign it or not. So once it signs it, what happens like basically all of the configuration files that we call it as manifests get copied down there at the, basically not copied down, basically it's like applied there at the node. So for example, let's look at some of the Puppet manifests. If you want to say something like print some messages or so, fine. If you want to install packages, pretty simple, straightforward. Just you have to specify the package name, like for example it's Apache 2 here, you have to say ensure it is installed, and after that if you want to do something, like suppose only this much part, these 3 lines, okay? That's what I love the beauty of the Puppet is that it's defining a configuration or writing manifest is super easy. Even if it's written in Ruby, everything, you don't have to know Ruby. I don't know Ruby at all. Maybe a bit of hello world or so. So you don't have to know Ruby at all. So you can write Puppet manifests, pretty simple, maybe like 5 minutes or 10 minutes going through that. And specifically when you're in your configurations, you can have Puppet master running on a 1, 2 or whichever machine, and you can have agents running whichever operating systems you want, be it Windows, be it Red Hat Baz, or whichever Linux distributions you want. So when I am saying Apache 2, okay, so it automatically, suppose if this command is going to be run on Yum based system, so there is nothing like Apache 2, there is HTTPD. So the Puppet, that's the factor basically, will understand from that if Apache 2, if it's a Red Hat based system, it's going to install the HTTPD there. Okay, that's a good thing we're there. And after that, what you want is that this is installed, and after that, service Apache 2 ensure it's true, enable true, required package Apache 2. As simple as that. So this will install the package, this will start the package, start the service there. So as simple, pretty simple here. You want to execute some remote commands. Same way. So we are writing all these things in Puppet manifest that is located in etc Puppet manifest. So we write a site.pp file. So you can write whatever.pp file, doesn't matter. And then there basically you specify the things. Like for example, this is like if you want to execute some command, remote commands on some machines. So what you are writing basically is like pattern is exec semicolon, what do you call these things as? Curly braces, and you have to provide the path. This is obviously important and simple. Execute the commands. Okay. Same way, creating users, deleting users, or doing whatever stuff you want. Just I provided some sample manifest. Yeah, so we can have certain attributes like name, UID, ensure, present, absent. Suppose for example, I want to delete some user here. Okay, so this will basically create the user Ashish Chandra. Okay, because I have said ensure is equal to present. Okay, so for the first time when it will run, so it will see is user Ashish Chandra present on that system. If it's present, okay, it's not going to do anything. It's going to report, okay, fine, Ashish Chandra is present. If it is not present, what it will do? It will install it. Sorry, it will create it. Okay, with all these configurations. Suppose, for example, a UID 1000 is reserved for some other user. It's going to report that thing because configuration mismatch is happening there. Some user is there for 1000 user. It's not going to create it again. It's not going to replace it. It's going to report it back. Okay. Similarly, in the next step, what I want is like I want to ensure that the user is absent. I don't want to have this user in the next configuration. I simply can say ensure absent. Similarly, for packages, I can say ensure it is absent. So that way, it's gonna manage it.
So this UID is must in all the configuration.
If you want to miss it, just gonna miss it. It has got some 10 or 15 options. I missed certain like GID. I missed which group it wants to be. If you want, if you can provide it, that's okay. If you don't, that's fine. If you remember the first time when I was creating a user from Puppet resource, some previous slides back, I only provided one username as well. Second one was the cell. Okay, you don't want to provide the home, fine. Just don't provide it home address, home ID, all these things, manage them, all these things. Just skip it, it's gonna do it. Okay? Yeah, there is a lot of attributes, I would not like to go into that part. Yep, things right now, whatever things that we have seen is like for example, we are creating a user, we have got some 1000 nodes to manage, it's gonna do it on all the 1000 users. Suppose if I had some 1000 users, but for each and every server, I want to have some configuration. This should be running Apache, this should be having MySQL servers, all these things. Okay, so that we call it as what a node specific configuration. You can specify what users should be there, what packages should be there on specific nodes. What you have to do is basically just specify. See, so far we have seen this much part, isn't it? Okay, just specify one more node or what was the host name of your node it is, or that you have defined in your etc host file. Okay, so it's gonna install or configure these only things that are specified on the under the heading of that node. So whatever configuration that we have made in this manifest will be applied to the Puppet node 1. Okay. Similarly, you can create and edit conf files. It's pretty simple files. Like I just give a simple example. Like just put wherever you want. Suppose I've got configure postgres.conf and all these things. Just provide a folder or just put like etc postgres.conf file there. Okay, and what you have to do in fileserver.conf, you have to just put the mount point. Okay, so it will be mounted like my files are present in this directory. Okay, and I said allow star means like allow all the files whatever there. Like specifically you can specify like postgres.conf there. So in the site pp dot what I'll say since every file every file will correspond to a different agent node. I can say like for Puppet node 1, look for this some file, ensure if it's present, and the source would be the mount point and this file. Okay, like for example, if I got a Postgres server running, what I'll say is like suppose Postgres node file, whatever the path of the file name is, that mount. This is the mount point, and from where check this, copy this file and copy and paste the file there. Okay, and we can do it. Completed pretty fast. Yeah, questions? See why I love Puppet is that it's first thing it's super easy. Same with Ceph. Super easy means you don't have to bother about a lot of things, lot of configurations to be done. Only a couple of commands and you're good to go. Second thing is that it's very fast. Very fast as in I had a small the place where I work, we are creating a cloud and I have got some 10 nodes with 400 GB each assigned to me, and in there my whole most of the times what I have to do, I have to spawn VMs. Okay, sometimes I have to spawn something like 2000 or 3000 VMs. Okay, for that, and you have to configure it, means like different services you have to run somewhere. I'm running database, so some like whatever the configuration, somewhere I'm running the memcache server, somewhere like I'm running Nova Compute, and obviously configuring 4000 nodes or maybe like 1000 nodes is not possible. Even spawning 1000 nodes is pretty big issue. Okay, suppose if you have to do it from VirtualBox, just forget it, you can't do it. Or even using virtual VMware EXSI server is pretty big pain. But I'm using this Puppet plus KVM to spawn VMs, and it takes me around 7 to 8 minutes maximum to 500 to 600 VMs with each 1 GB RAM. Does it pretty fast.
So how is the provisioning? You use a plugin or is it?
Just write up simple the Puppet's manifest. Just provide the node what were the host names. What it will do basically, what were the host names you are provided, it's going to just populate the host.xml file.
What about the credentials to, suppose I'm doing I need to provision cloud. So what about the credentials?
Credentials you don't have, if you want to create it, it's like a normal user, okay fine, you can use a ready-made IMG image or AMI image or whatever, or maybe like you can just push in your PEM file that you said.
There must be some module to do that as well.
Yeah, this is there, but I have created it my own.
Okay, got it.
I open source it as
You
well.
can just create a, you can just, what people do is use an external resource and have your key in there, have your public key in there, and then just provide the file name. Like when he says the
Docker event?
home directory is this.
It has been cancelled.
That has been postponed. That has been cancelled for them.
Okay. Because I didn't get a message or anything then.
Actually,
It was a random last moment decision.
Okay.
Because we didn't have enough people and also it's raining.
Yeah, I know
So
it's
we
raining.
won't have anybody else coming
Okay,
in,
okay.
so we cancelled it last moment. Right?
Okay, fine.
He just walked out like 2 minutes back.
Who?
The guy was supposed to speak on Docker.
Yes, I saw him. Yes,
Yeah,
I was
so-
wondering what happened. Whether there's a confusion on the time or something,
Yeah, we have been a little late. It's been raining, so we're not sure. So we want to like finish up quickly. We didn't expect anybody else to come in also right now.
Fine, yeah, thank you.
Sorry about that.
Yeah, so
What's your name? We can tell him.
I'm Nikhil Thakkar.
So this was the issue that I was finding. For that I learned KVM and a new Puppet, and Puppet came to my rescue. So sometimes like if I don't want to do something, I just want to chill out, I'm saying okay, actually I'm spawning VMs. Even if it does in 7 to 8 minutes, no one is going to believe that you are spawning 500 VMs in maybe like 8 minutes or 10 minutes. Never, not possible. That's what basically this configuration management system is does. And as Aditya said, like Puppet is known to scale. Like Sun is using for some 2 lakh plus nodes, 2.5 lakhs or 3 lakhs nodes, and a lot of companies are using it. It's pretty easy to learn. That's it.
What are the issues you faced as of now?
See, issues that you're gonna face a lot of times is that what I expect most of the times I feel is like so hostname resolving error issues a lot of times. So most of the times you never like the xcconf host file that I have shown you there. Everywhere I have configured a FQDN, but it is not recommended. Nowhere it is written that you have to use FQDN. But if you don't use FQDN, you're gonna find that the Puppet attaches it for you every time. Last night I was doing it. I had a built-in router everywhere. It's like when I'm just going to log, it's like saying that okay, this host, my host name and .built-in. Why is doing it? So Puppet does it for yourself. So this is not actually the issue.
Puppet can be sometimes hard to debug. If your code fails for some reason, it has happened to me sometimes. It gave me error messages. Problem was somewhere else. So,
this thing is agreed.
Writing code is not the issue over here. Setting it up can be a challenge.
Yes, that was like when we were using Puppet 2.7 2 years back actually, and at that time the setting of Puppet itself was big issue. Means you have to configure all the dependencies yourself. So right now it's pretty easy. Like install Puppet Master, does it everything.
Since which version of Puppet?
Puppet 2.7 it had was there, but after Puppet 3 everything was gone. Everything is like super fluid, easy to learn, easy to do. So
you use Puppet to configure all the VMs which you have already spawned,
yeah,
right?
yeah.
How do you spawn them? Like using KVM,
Yeah.
but like
you have to specify. You have to
yeah, exactly. So that is what I'm talking about.
You have got a host machine, so you have all the packages, KVM packages installed. After it, so to spawn a VM using KVM, what you require? One image file. Second thing you require a XML file. Okay, you can just write the whole command for that. That's fine. But in there you are specifying all the XML files, configurations. What all configurations that I require? Just I'll say you. First one is the UID, not required if you want. Second is the word, how much RAM you want to provide. Okay. Third thing you want to is like how many virtual CPUs you want to provide. Fourth thing is like network interfaces, whatever network interfaces you want to provide. MAC address, what MAC addresses you want to provide, that could be dummy, isn't it? So you just provide those dummy things in your host.xml file, or it's a certain bunch of stuff in the XML file that you want. So you can generate it on the fly, isn't it? So what I did basically in Manifest, I wrote all these things, okay? And generating the MAC addresses, UID and all these things. And what it does basically, it creates separate folder for every and copies the same image that I have configured. I have actually a local copy of the image and uses it to spawn VMs.
So are all of them in this same subnet, or do you have like defined it as a different subnet?
No, right now it's in the same subnet.
Everything is in
Same subnet, yes. You can make it in different subnets, but maybe like I don't know. Or
there is
maybe
a Puppet module which is written on top of libvirt library.
Yeah, you can use that too.
That module takes these parameters.
If you want, you can use those. But what happens like Puppet does have more than 3,000 modules available on Puppet 4. More than 3,000 is like if you want to do something, you don't have to start from scratch. Simply just take it from there. You are good to go. 90% of the time, if I have to do something, I just copy the things from there and maybe like configure it or maybe like tweak it a bit according to my changes, and I'm good to go. But 90% of the times, it's perfect. You don't have to write your own module. If you want, you can write it, depends on your users. Yeah, just things like that I like with Puppet is that it's very fast. I don't know, I haven't compared it with anything else. don't know what
So
others.
you run Puppet manually on those servers or you let it run?
See, what I do is like when you just have a spawn VMs, you have your IP addresses, or simply you can SSH to those VMs. Okay, so I'm not using SSH. I have the SSH key pairs there. So what SSH to those VMs and install all the packages that I require for specific. See, that's what I showed you there. Like we have node specific configuration that we are writing. So once those nodes, actually, what happens like there is a class based. I skipped that. Not script, I didn't have that thing in my wiki. Class based approach there. It's like what will be done afterward. Okay? So it's like once it has done, it will inherit this thing, It's like step by step. So I have got certain files like systems.pp, after that os environments.pp, then kvm setup.pp. So first of all it will have system.pp ready, after that environment setup.pp, then it will go for the kvm setup. So this is the way it is being done right now.
I don't know about Puppet 3, but in Puppet 2.7, the default value was 20 minutes. It would go and check out every 20 minutes.
Yeah. So it's like right now it's also the 30 minutes only. So it's like every 30 minutes a Puppet agent basically goes and pings the master for some changes. But if you want, if you can run Puppet agent at whatever time, you can just configure it in puppet.conf at what time you want to run it. So why 30 minutes is too much time, isn't it? So if you want to configure it, you can configure it for 1 minute, maybe 30 seconds. But suppose you have got 10,000 servers and every 30 seconds they are polling to the master.
But Puppet is used for state management, right? You define the state of the server and then that will be applied. So how are you spawning 3,000 or 4,000 VMs where Puppet is not supposed to provision anything?
Why?
That is what I asked him. How does he spawn all
There
those
is a
things?
separate
He's not using Puppet for that.
Yeah, I'm using that.
Puppet is
There must be
for
some
that.
other link that must be used.
So there is a Puppet module
Okay.
that is created, which takes which takes a file as a parameter image.
Oh, maybe like I can show you the
makes a
way we are
libword
doing
call
it.
to the KVM. KVM, the libword call is a one-liner call which says spawn a VM with the parameters, how much memory you want and how much CPU you want.
That's just fine.
And that's how it provisions it. You can just directly use libword API and make that call, but a better way is to use Puppet itself. But the issue there is that all your VMs will be very similar.
Yeah.
So if you want to do resource management, you can use Mesosphere. Mesosphere is a much more better. Jenkins and Mesosphere has this dynamic way of making sure that you use optimal resources properly. It's an offer-based system. So, but you're right. Puppet is not the tool for provisioning. It doesn't have any construct till now.
Are you sure?
It's not.
Yeah. Puppet doesn't have a provisioning construct. It's a module written by a person, which is just wrapping a provisioning thing.
No. I'll just maybe if you guys are interested, I'll walk you through this.
I'm not going through too much of this provisioning, but that's it. What is it like? Ansible, I've tried provisioning Rackspace and EC2 using Ansible. I think it's the same thing as what Puppet does.
Yeah, if you want to walk through how it is being done right now, how it's provisioning the resources. Okay.
You're provisioning the resources.
Yeah, how I'm provisioning it. See, simple. I'm just saying this is a class that I have written. KVM setup inherits KVM environment. So there is one class file that I have configured where I have written that what should be the environment before starting it. So when I'm saying KVM setup, so it will do it first. KVM environment. Okay.
So
and I have configured one virtual interface, virtual
we are not
box.
expecting people to come
For PH0 or so again it is inheriting RM native network because I want all the VMs to have internet or whatever configuration interfaces that I want. Okay, and in this KVM boot, what I have specified things like VM name, fine, memory, vCPUs, interface, or
Meetup right now.
the source we want to have an image or SD or like image URL from where you want to take. So this is a local. That's why it's pretty fast.
Show the command. Show the command.
Show me the call
Show
where it
the
is
command
happening.
which does provisioning.
So the call is in simple. What you have to run is like simple. You configure the site.pp file, or in my case it is d2. I have configured a file here. Yeah. So there are different files here. So it's like for production, staging. I should not show you, but okay, fine, because I have written it myself. So what actually in this is just like a site.pp. Okay. So whatever names like what we are doing is like you are providing the IP addresses, DB IP, host IP, or and we are configuring like for example I have in this place I am configuring my 5 VMs. Okay.
No,
For my setup.
scroll down. So scroll up. These are just parameters.
Yeah.
Where is the actual command which is going to say create VM? On the KVM machine, there has to be a call that goes and say, give me that VM. Where is that call?
Call as in I didn't get.
Somebody has to tell the KVM to provide the VM.
Simple. Just say p-apply. That's going to do that.
So
p-apply and the file name. So what you are providing is like when I say p-apply t2.pp. So whatever things it is there, it's just like when you are saying in Puppet apply and the site.pp file. So whatever configurations are there on this node, it will just run there. So right now it's not a master slave configuration. Okay, it's all master because I have got one server. In that server only, it's first of all it spawns all the VMs. Again, it takes the part of what the Puppet master slave configuration and configures the VM. The first thing is it spawns the VM, and second after that it takes the Puppet master configurations.
Because in Puppet, what I know is for provisioning there are providers. You can say that use these providers for provisioning. And at that time you can provide Google Compute providers, KVM providers. So you can plug in the providers.
This is the p-apply file basically I use. I call it as public. This is simple the script. What basically just forget about all these things. So what basically I'm running here is Puppet apply. This module path I'm providing, and it creates the site.pp on the fly from the environment that I'm providing. Okay, whichever environment you want.
Okay.
So just bootstrapping the things.
So site.pp has that command. So which means
no, it creates the site.pp on the fly.
What he's trying to say is there is no command.
See, there is nothing like a command that you have
somebody
to
has
run.
to run the command, yeah.
So there's a module built in.
Module itself does that. So it's a library which is running the exact command. He's not doing that.
Correct.
Okay.
Okay, so you're using.
And for your use case, you can actually use Vagrant and Docker itself. Like Vagrant take this Docker image, apply whatever you want, create so many. So you just have like one Vagrant the site file inside Vagrant folder, and it will create everything for you.
That's the beauty of it. That's what I'm saying. It's like you can if you want to make it dirty, you can make it dirty. If you want to make it easy, you can make it easy. Depends on the uses. So in the whole of the file, I'm doing nothing but I'm doing this line.
Yeah.
So I'm just running a site.pp that is being generated here. If you want to see here, it is generated here. Okay, whatever the environment that I'm providing, so it is creating the site.environment.pp accordingly. So suppose if I want to make a staging environment, so I'll provide the staging.pp file there. So in there you can specify whatever hosts you want. Like for example, I am having 5 hosts. Like for example, I have got 5 hosts here. So in there I have configured the host machines. You can configure, suppose if you have got 10 hosts, on all hosts you want. Like for example, T2, you can configure memory, virtual CPUs, MAC address, UID, whatever parameters that you are providing it, you can do it there. Create the VM.
If you want to externalize these parameters, on the fly.
On the fly, as in?
Because this is a PP file, you have to compile a PP file.
Yeah.
Okay. If you want to say that, okay, right now somebody asks for a host. The help desk ticket comes in and they say, give me a host with this sizing. And you want to dynamically provision it with Puppet.
No.
Okay, without manual intervention.
No, you can't.
What you have to do is?
See, in Puppet Master, you have to specify the configuration. Oh, sorry.
What you have to do?
You have to.
I think he is giving you a solution.
Yeah.
What I'm saying is, to do that, there is this concept called as Hira.
Yeah.
So Puppet Hira
database type.
Yeah, it's a very simple thing. It just externalized all these parameters, the same parameters you just externalize, put them in a separate file. And so in Hira configuration, you can change those files on it. These are YAML files.
Okay.
You just add that entry from the service desk ticket, and then you run Puppet. Next time it is going to pick that up, and so that way you can automate the entire workflow without any manual intervention, without any the PP file does not need to compile every time. The compiled version would just use a new data. So if you separate data out from your module, it makes it extremely powerful.
Have you used data?
Hira?
Yeah.
Yeah, extremely.
In 2.7 or in 3? Because in 2.7, I was
2.7
experimenting with
I-
Hera about a year back. It was like very, very shitty. I couldn't, it was not running that well. So
After 3 it became pretty good.
Yeah.
It became pretty
no,
seamless.
after 3 it was like kind of the default thing. Right?
Yeah,
It is default now.
Yeah.
Now it is default. So
Hira
I think
makes that
that's it.
separation of data from the config very, I mean,
Like for example, if
See,
you want to
these
use your
things-
MySQL password, right? You don't want that password in your config file.
Correct.
Right.
So for that you'll use Hera.
yeah.
And for other stuff which you don't want in your, like what he's giving an example of also, right? Stuff you don't want in your config file, you can use Hera for that.
correct.
Yeah, config file should be reserved only for the code purposes,
Yeah.
not the data purposes. So.
Correct.
Yeah.
So that's the thing is like if you're writing manifest in Puppet, you have to specify everything, username, password, and all these things. So that is not serious.
So
You can just provide a variable and do what and
Yeah.
like yeah.
These basic things, now in Chef what I found is since Chef came very late, means 5-6 years late after Puppet.
They learned.
Here they have learnt a lot. They have a concept called as data bag, which they keep it separate. All the data they keep it separate. Code they keep separate. So they have created these provisions already to make it powerful. So in the fundamental step itself, you have roles, hosts. You are just matching the run lists to a host. So the advanced topics of Puppet, they are like fundamental topics in Chef.